Have you ever looked up at the night sky and felt comforted by it? Not amazed, not inspired, comforted. A dark field, a few clean points of light, nothing moving fast enough to frighten you, nothing loud enough to sound dangerous. The sky has a way of making the universe look composed, distant, almost polite. But that impression is false. What you call a star is not a decoration in the darkness. It is matter under such extreme pressure that atoms lose their ordinary identities. Light is manufactured by mass being destroyed, and gravity is held off only by a continuous act of nuclear violence. The sky looks still only because the violence is far away. And even that stillness is an illusion. The light reaching your eyes tonight did not leave those stars tonight. Some of it began its journey before you were born, some before your parents were born. In many cases, what you are seeing is not a present scene at all, but a delayed report. A star can change, collapse, even die, and for a while the sky will go on, presenting the old version to you anyway. That is the first fracture in the picture. The night does not show you what is there. It shows you what arrived. So, the first thing to give up is the idea that the sky is immediate. The second is even harder to surrender. Because a star does not only look peaceful, it also seems conceptually simple. We are taught to file it away early in life. The sun is a star. Stars are like the sun. They are giant balls of hot gas. They burn in space. They give off light and heat. That feels sufficient, clean, finished. The kind of explanation you can carry for years without noticing that it never really touched the thing itself. But a star is not a fire. Fire is chemistry. Fire is atoms rearranging their outer electrons, breaking one set of molecular bonds and forming another. Fire belongs to the thin outer skin of matter. It lives in wood, paper, fuel, oxygen. It is local, temporary, ordinary. A star has nothing to do with that. A star shines because gravity has driven matter so deep into itself that the nucleus of an atom can no longer remain an untouchable center. In the core of a star, hydrogen is forced into encounters so violent, so improbable, and so relentless that separate nuclei begin to merge. A little mass disappears in the process, not metaphorically, literally, and that missing mass leaves as energy. The warmth on your face from sunlight is what lost mass feels like after 8 minutes of travel. That alone should change the mood of the sky. Because it means the most familiar object in human life is powered by a conversion so severe that ordinary language hides it from us. We say the sun rises, we say the sun is shining, we say it is warm out. All of that is true in the same way it is true to say a heart is beating. True enough to live by, not true enough to understand by. Inside the sun, the pressure is immense. The temperature in the core reaches roughly 15 million degrees Celsius. Protons, which should repel one another because they carry the same electric charge, are forced so close together that quantum mechanics gives them a way through. Not a dramatic way, not a clean way, a statistical way, a tunnel through what classical intuition would call impossible. That is how the process begins, not with flame, but with crushed probability. And from that microscopic concession comes everything else. Photons created in the core do not stream cleanly outward like light from a lamp. They spend enormous amounts of time ricocheting through the dense interior, absorbed and re-emitted, scattered and delayed, taking a path so tangled that the energy released in the center can take thousands to hundreds of thousands of years to work its way toward the surface. By the time sunlight leaves the photosphere and crosses the vacuum to Earth, its history is already ancient. The daylight feels immediate only because your senses cannot register how long the process has already been underway. You are not standing in fresh light. You are standing in the last thin release of a much older struggle. And that struggle has a shape. Gravity is always trying to make a star smaller. It gathers gas inward, presses layer against layer, insists on concentration. Fusion pushes back. Energy released in the core generates outward pressure. And for long periods of time, these two tendencies nearly balance. That balance is what we call a star. Not a thing, exactly, a standoff. That is one of the deepest errors in how we imagine the cosmos. We think stability means peace. But in many parts of nature, Stability means conflict maintained with exquisite precision. A star is stable in the same sense that a body can be stable while every cell inside it is busy. Stable in the same sense that a civilization can look calm from a distance while millions of negotiations, corrections, and failures are happening underneath the visible surface. The star is not serene. It is successfully resisting collapse. For now. And that phrase matters more than it first appears to, because everything that makes a star luminous also makes it temporary. A star exists by spending itself. It shines by consuming the conditions that allow it to shine. Every second, the sun converts about 600 million tons of hydrogen into helium. Roughly 4 million tons of mass vanish into energy each second. Again, not symbolically, physically, the sun is not being dramatic about it. The scale is simply beyond the habits of human feeling. The sky looks calm because human intuition was not built for stellar bookkeeping. If the sun were a campfire, you could understand it instantly. You could picture the wood, the smoke, the ash, the fading coals. But a star does not leave behind ash in any ordinary sense, and it does not live inside any ordinary time scale. It is too large for instinct and too patient for panic. That combination is dangerous to thought. It invites simplification. Anything both overwhelming and slow is likely to be mistaken for background. That is what stars became for us. Background. Ancient people read stories into them. Navigators drew routes through them. Farmers used them as clocks. Lovers used them as witnesses. Poets used them as symbols of permanence. And none of that was foolish. Human beings always begin with the visible version of reality. We have no other entrance. But the visible version is not the final one. It rarely is. The deeper truth is colder. A star is a temporary answer to gravity. That answer can last for millions, billions, even trillions of years depending on the mass involved. But temporary does not mean trivial. Temporary is enough to make planets. Temporary is enough to fill interstellar darkness with usable energy. Temporary is enough to let chemistry climb into biology, and biology into memory, language, and fear. The entire continuity of life on Earth depends on a star managing not to fail too quickly. And yet failure is built into the contract from the beginning. The core changes, the available fuel changes, the balance shifts, pressure and gravity renegotiate the terms. Every star is living on a countdown written not on its surface, but in its center. The bright disk in the sky is only the outer expression of an argument being carried on far below anything you will ever see. This is why the old phrase, "we are made of stardust," is both beautiful and misleading. Beautiful, because it recognizes kinship. Misleading, because it sounds gentle. Dust sounds soft. Dust sounds passive. Dust sounds like the settled remains of something ancient and harmless. But the history inside a star is not soft. The matter that will one day become rock, ocean, air, blood, and bone does not begin as a poetic haze. It begins under compression so intense that matter itself is forced to reorganize. If you want to understand what a star gives to the universe, you cannot begin with glitter. You have to begin with pressure. Before a star becomes light, it becomes pressure. That is the hidden preface to almost everything that matters later. Because once you stop calling a star a fire, the entire sky changes character. Those points above you are no longer ornaments. They are engines, delayed, distant, self-consuming engines. Some are small enough to burn with almost miserly restraint for spans of time so long, the present age of the universe is only an opening act. Others are enormous and extravagant, spending themselves so fast that their brilliance is already a kind of confession. Mass decides temperament. The larger the star, the less patient its life. The universe is full of lights, but not all lights mean the same thing. Some stars endure because they almost refuse to happen. Others blaze because they are living beyond their means. And none of them were born into peace. Because gravity does not ignite a star by kindness. It builds one the way winter builds ice across a lake. Layer by layer, pressure by pressure, until a threshold is crossed and the whole system changes state. The light comes later. First, there is darkness gathering itself. First there is cold matter falling inward. First there is a cloud that can no longer remain a cloud. The star is already implicit in the collapse. And once that is visible, the night sky stops being a painting. It becomes a record of matter being driven, again and again, into forms it would never choose on its own, because that collapse is the real beginning. Long before a star is visible, before there is any surface to shine or any light to cross the dark, there is only a region inside a cold molecular cloud where gravity has started to win. Not dramatically at first, no explosion, no clear dividing line, just a slight asymmetry in a vast, frigid haze of hydrogen, helium, dust, and trace heavy elements left behind by older stars. A little more mass here, a little less support there, a quiet imbalance. And once that imbalance deepens past a certain point, the cloud stops being scenery and becomes a future. These clouds are enormous beyond ordinary imagination. They can stretch for dozens or even hundreds of light years, with temperatures so low that thermal motion offers only weak resistance. Seen from a distance, they look soft, almost decorative, dark lanes threaded through bright nebulae, gauzy structures suspended in space. But that softness is deceptive. A molecular cloud is a warehouse of unrealized consequences. Inside it are the raw materials for stars, planets, atmospheres, oceans, carbon chemistry, perhaps even nervous systems. The cloud does not know that. Physics does not need to know what it is making. It only has to keep following its own pressure gradients and gravitational rules. The first true movement is inward. As gas begins to fall, gravitational potential energy is converted into heat. That is one of the most important patterns in the universe. Falling becomes temperature, collapse becomes brightness. A cloud fragment, once dark and diffuse, grows denser and warmer as it contracts. The center thickens. Material spirals inward. The infalling gas does not simply drop like rain. It twists, collides, shears, and settles. Angular momentum refuses to disappear, so the collapsing cloud flattens into a rotating disk around a growing central core. Even before the star exists, a structure has already emerged. Center, disk, flow, direction. This is not yet a star. It is a protostar, and the distinction matters. A protostar can glow. It can heat its surroundings. It can drive spectacular jets from its poles, narrow beams of accelerated material that lance outward for light years, as if the forming system is trying to shed excess motion. It can carve cavities in the surrounding cloud and announce its presence in infrared wavelengths long before it becomes visible in ordinary light. But it is not shining because fusion has fully taken command. It is shining because collapse itself is releasing energy. That is the first correction to another quiet misconception. We often imagine that once a star turns on, the story begins. But the prehistory is already violent, already structured, already full of thresholds. The star is not switched on like a lamp. It is cornered into existence. And the corner is narrow. For a collapsing core to become a genuine star, conditions at the center must grow extreme enough for hydrogen nuclei to begin fusing into helium at a rate capable of pushing back meaningfully against gravity. That sounds almost straightforward when said quickly. It is nothing like straightforward. Hydrogen nuclei are positively charged. They repel one another. Under ordinary conditions, they do not merge. They keep their distance. As basic electromagnetic logic says, they should. So, a star is born only when matter is driven into a state where ordinary refusal stops being enough. Core temperatures rise into the millions of degrees, densities increase, collisions become relentless, and then quantum mechanics enters, not as an exotic side note, but as the hidden permissions slip underneath starlight. The protons do not need to overcome their mutual repulsion in a classical, head-on sense every time, sometimes, because the universe at small scales is not governed by common intuition. There is a finite probability that they tunnel through the barrier. It is rare, individually improbable. But a stellar core contains so many particles under such persistent conditions that the improbable becomes inevitable. That is how stars begin to truly shine. Not because the universe contains fire on a larger scale, but because gravity can force matter into a domain where improbability, repeated enough times, becomes architecture. A star is born when collapse discovers a loophole. That should change the emotional texture of the idea. We like births that feel clean and declarative, a beginning, a first breath, a moment of emergence. Stellar birth is stranger than that. It is less like a first breath than a successful resistance to suffocation. A protostar contracts, heats, and sinks deeper into its own problem until the core finally produces enough outward pressure from fusion to halt further collapse. Only then does the object enter the long, deceptively stable phase we call the main sequence. Only then does it become the kind of star that can persist for millions to trillions of years, depending on its mass. Mass is the hidden lawgiver here. A small star and a large star are not the same story told at different sizes. They are different temperaments born from the same physical framework. A low-mass red dwarf compresses matter enough to ignite fusion, but it does so with restraint. It sips. It burns slowly, efficiently, almost grudgingly. Such stars can outlive every more dramatic star in the cosmos by staggering margins. A massive blue star does the opposite. Its greater weight crushes the core harder, drives temperatures higher, accelerates fusion, and creates a brilliance that is inseparable from waste. It lives brightly because it lives recklessly. This is one of the most counterintuitive truths in stellar physics. Bigger does not mean longer. Bigger means faster collapse held off by faster burning. Bigger means extravagance. Bigger means the star spends the future to purchase the present. Some stars endure because they barely trust themselves to shine. Others blaze like a fortune being thrown into a furnace. And this divergence begins almost immediately, because mass determines pressure, pressure determines core temperature, and core temperature governs how aggressively fusion proceeds. In that sense, the destiny of a star is written astonishingly early, not in every detail, but in its broad moral shape, frugal or prodigal, long-lived or brief, patient ember or short-lived beacon. The sky contains all of these biographies at once. But even before those biographies unfold, the environment around a new star is changing in ways that matter later. The disk of gas and dust encircling many young stars is not decorative residue. It is the place where grains collide, stick, shatter, reaccumulate, and gradually begin the long process of planetary construction. Silicates, ices, metal-rich particles, carbon-bearing compounds, these do not arrange themselves into worlds immediately. They churn inside a disk still shaped by turbulence, radiation, magnetic fields, and migration. But the stage has been built. A star is not merely an isolated object coming into existence. It is often the central event in the formation of a system. This is why stellar birth is one of the most consequential transitions in the universe. It does not only create light, it creates a stable center around which complexity can gather. Not always, not safely, not automatically, but the possibility opens there. Look at an image of a stellar nursery, and the eye is tempted by the colors: pink gas, blue reflection nebulae, dark filaments, brilliant newborn stars hidden in glowing cavities. Beautiful, yes, but the beauty can mislead by making the process seem painterly. The actual scene is harsher: supersonic turbulence, gravitational fragmentation, magnetic interference, radiation pressure, collisions across scales too large for instinct and too cold for comfort. The birthplaces of stars are not serene gardens. They are regions where matter has lost the luxury of remaining diffuse. Again and again, astronomy punishes the same human error. We mistake distance for calm. What looks soft from here can be violent beyond endurance. What looks decorative can be a mechanism. What looks eternal can be temporary. The star-forming cloud, the protostar, the disk, the jets, none of them exist because the universe is trying to create beauty. Beauty is what our minds call certain arrangements of lawful process when viewed from survivable distances. Up close, the real word is stress. And stress is exactly what a star inherits from the moment it is born. Because ignition is not victory. It is only the beginning of a negotiated balance that must now be maintained from the inside. Gravity does not vanish once fusion starts. It remains, always, pressing inward. Fusion does not annihilate collapse. It postpones it. Every second of a star's life is therefore a managed equilibrium between inward weight and outward release. That is the true condition of stellar existence. Not rest, not triumph, ongoing containment. You can see why ordinary language fails so easily. To call a star a giant ball of gas is not wrong in the crude sense, but it empties the object of its real drama. It is like describing a cathedral as a pile of stone, or a mind as a collection of cells, technically anchored, spiritually vacant. A star is matter arranged into a prolonged argument with gravity. The argument can last longer than civilizations, oceans, species, even planets, but it is still an argument. And because it is an argument, there is always the possibility of losing. That loss does not come all at once. Not yet. First comes the long period that, from a human perspective, looks like permanence. A star settles into a pattern. Core fusion proceeds. Energy works its way outward. Radiation leaves the surface. The surrounding system adjusts. Worlds may form. Orbits stabilize. Chemistry begins to explore what repeated energy input can do over immense spans of time. From far enough away, this looks like order has been achieved. But the order is purchased by expenditure. The hydrogen in the core is not infinite. The exact balance holding the star up is not static. Each act of fusion changes the composition of the core slightly. Each change alters the pressure profile. Each alteration nudges the future. A star shines by rewriting the conditions of its own survival. That is the deeper reason every star is temporary. It is not just burning fuel in a generic sense. It is transforming the very interior whose structure determines how long balance can continue. The surface does not show you this directly. It rarely does. The visible universe is full of beautiful disguises. Yet beneath the steady light of any star is a quieter truth. Every luminous object in the sky is living on internal change. The star looks finished. The star is actually spending itself. And once that fact settles in, another one follows close behind. If a star's stability is only a long negotiation, then the real story is not that stars shine. The real story is what happens when the negotiation begins to fail. And the failure does not begin at the surface. That is another instinct the sky trains into us too easily. We think visible change is the important change. We watch for dimming, swelling, eruptions, collapse. We imagine the drama beginning when the star starts to look different. But the real turning points happen where no eye can go. In the core, in the slow conversion of one interior into another, in the changing arithmetic of pressure, temperature, and fuel. A star does not die the way an animal dies. It does not stop because some external blow arrives. It dies by exhausting the precise internal bargain that allowed it to exist in the first place. For most of a star's life, hydrogen fusion in the core provides the outward pressure needed to resist gravitational collapse. That long interval can be astonishingly stable. In stars like the Sun, it lasts for billions of years. So long, in fact, that human civilization fits inside it like a breath inside a winter night. Entire biological histories can unfold under a star that appears unchanged. Continents can drift. Species can rise and vanish. Ice can advance and retreat across worlds. And all the while, in the core, hydrogen is being consumed atom by atom, probability by probability, pressure by pressure. Eventually, the balance shifts. The hydrogen in the central region grows depleted. Helium ash accumulates. The core becomes denser. With less hydrogen fusion happening at the center, the outward pressure weakens. Gravity, which never left, begins to compress the core further. And compression is never merely compression. Compression means higher temperature. Higher temperature means new possibilities. Layers outside the core, still rich in hydrogen, can heat enough to begin fusing in a shell around the inert helium center. This is where stellar life stops looking simple. Because the star does not move cleanly from one state to another. It reorganizes, the core contracts, the outer layers respond, the envelope expands. Surface temperature can fall even as the total luminosity rises. The star swells outward into a red giant, becoming physically enormous while its center grows smaller, hotter, and more stressed. To an uninformed glance, this might look like growth, but it is not growth in any biological sense. It is destabilized architecture. The star is changing shape because its original way of surviving is no longer enough. It is trying new terms. That phrase may sound too human for physics, but the process earns it. Stellar evolution after the main sequence is a sequence of increasingly difficult negotiations with gravity. Each new stage is both a temporary solution and a sign that the previous solution has failed. Hydrogen in the core once did the job, then hydrogen in a shell. Later, if the star has enough mass and the temperature rises high enough, helium nuclei begin to fuse into carbon and oxygen. For stars around the sun's mass, this transition is already dramatic enough. In stars with much greater mass, the sequence becomes more desperate still. The deeper the star goes into its own life, the stranger its interior becomes. Picture not a smooth, glowing sphere, but something more layered, more tense, more internally divided. In a massive star near the end, different fusion processes can occur in different shells. Hydrogen farther out, helium beneath that, then carbon, neon, oxygen, silicon. Each stage requiring higher temperatures, each burning faster, each producing heavier nuclei. The star becomes an onion of increasingly urgent physics. What began as a relatively simple hydrogen-burning body becomes a nested crisis, each layer briefly holding, while the center races ahead into harsher conditions. And the timescales begin to collapse. Hydrogen burning can last millions or billions of years, depending on the star's mass. Helium burning is shorter, carbon shorter still. Advanced burning stages in the heaviest stars can proceed on scales so compressed that what took eons to build can be undone in years, days, even less. This is one of the great asymmetries of nature: long preparation, rapid ending. A star spends most of its existence establishing the conditions for its final catastrophe, then crosses the last thresholds with shocking speed. We like to think of the universe as patient. Often it is. But patience is not gentleness. Sometimes patience is only the long accumulation before a violent release. And inside a massive star, that accumulation has a direction. Every new fusion stage extracts a little more usable support from the elements available. But the sequence cannot continue indefinitely. Nuclear fusion does not produce energy in the same way for all nuclei. There is a deep fact hidden in the periodic table, one that almost feels like fate once you understand it. Light elements can release energy by fusing into heavier ones, but only up to a point. That point is iron. Iron is the wall. Not a wall in space, not a visible boundary, a wall in nuclear economics. Up to iron, fusion can help support a star. Beyond iron, fusion starts to cost energy rather than release it. The process that once paid the pressure bill becomes an expense the star cannot afford. And because the entire life of the star depended on being able to turn mass arrangements into outward support, this is more than a technical limit. It is the place where the old strategy ends. A massive star can build a core rich in iron through successive burning stages, but once that iron core grows too large, it becomes a terrible kind of success. The star has manufactured the very condition that strips it of future options. Gravity presses inward as it always has. But now there is no next easy fuel waiting in reserve, no deeper layer of profitable fusion to reassert equilibrium. The center becomes a trap made of its own achievement. That is the hidden cruelty of stellar life. The more productive the core has been, the closer it may come to a state where productivity itself can no longer save it. The universe can build almost everything from a star, but it cannot bargain past iron. That line matters because it transforms the story. Until now, the star has seemed like a generator of light, heat, and structure. Enormous, yes. Violent in detail, yes, but still fundamentally intelligible within the language of equilibrium. Gravity pushes, Fusion pushes back. The star persists in the balance between them. Once iron dominates the core, persistence becomes fragile in a new way. The star is no longer merely aging. It is approaching a physical dead end. And dead ends in astrophysics do not behave like dead ends in ordinary life. They do not announce themselves with stillness. They announce themselves with runaway collapse. The iron core, unsupported by further energy-releasing fusion, begins to give way. Electrons are forced into protons, forming neutrons and neutrinos in enormous numbers. Pressure support drops. Collapse accelerates. The core falls inward at a speed human intuition has no language for, because the event outruns every pace familiar to biology. A structure that held itself up for millions of years can lose that hold in less than a second. Less than a second. It is hard to overstate how important that contrast is. A massive star may spend an immense span of cosmic time building layer upon layer of complexity, only for its center to become catastrophically unstable almost instantaneously once the last thresholds are crossed. This is not merely the end of a luminous object. It is the sudden refusal of one set of physical rules to keep granting extensions. And yet even here, the truth deepens, because collapse is not just the end of the star's old life. It is the beginning of the conditions that make the next kind of universe possible. This is where ordinary language starts to fail again. We say a star explodes and think we understand the event, but explosion sounds singular, almost clean, a moment of outward force, a blast. In reality, the sequence is stranger. First comes implosion. The core caves inward, density skyrockets, neutrinos flood out. In some cases, the collapsing core stiffens when nuclear densities are reached, creating a rebounding shock. In the turmoil that follows, with neutrino energy and extreme matter dynamics involved, the star can tear itself apart in a supernova. Outward violence, born from inward defeat. A supernova is what happens when a star stops being an object and becomes an event. The visible flash is the least complete part of the story. What matters more is what those conditions do to matter itself. Temperatures and neutron fluxes become so extreme that nuclei can be forged or transformed in ways impossible during the quieter phases of stellar life. Many of the heavier elements that chemistry depends on are either produced or dispersed in these deaths, while some of the heaviest are thought to require especially neutron-rich events, including the collisions of neutron stars. The broad truth remains firm even where the details branch. Without stellar death, the universe would remain chemically impoverished. No rock, no metal-rich planet, no calcium lattice in bone, no iron in blood, no phosphorus cycling through metabolism, no world with enough elemental variety to become biologically interesting. The star's failure is the universe's opportunity. That is the turn. That is where the sentimental phrase about being made of stars begins to harden into something more honest. Not because the phrase is false, but because it is incomplete. You are not made of starshine. You are not made of some vague celestial essence. You are made of material that had to pass through pressure regimes so severe that entire stars lost their identities to create it. The body is downstream of catastrophe. And once you see that, the glow of a star changes again. It is no longer only beautiful, or distant, or ancient. It becomes preparatory. The calm surface is hiding a future in which equilibrium will fail, matter will be reprocessed, and the contents of a star will be returned to the galaxy in altered form. The light is real, the warmth is real, but inside that reality is a more severe one. Stellar life is a temporary act of containment whose ending is often more cosmically fertile than its stable years ever were. Which means the real story of a star is not just how it shines. It is what its death leaves behind. And what it leaves behind is not debris in any ordinary sense. That word is too casual. Debris is what remains after something breaks and loses importance. But the aftermath of stellar death is not unimportant matter scattered through space. It is matter that has been changed so deeply that the rest of cosmic history can now do things it could not do before. New chemistry becomes possible. New minerals become possible. New planets become possible. In the long aftermath of a dead star, the universe gains options. That is the deeper pattern beginning to emerge. A star is not just a source of light. It is a converter of simplicity into structure, first by fusion during its life, then by dispersal and transformation during its death. The bright years matter, but the inheritance matters more. Because before the first generation of stars, the universe was chemically poor in a way that is hard to feel. After the Big Bang, there was an enormous amount of hydrogen, a substantial amount of helium, and only traces of lithium and beryllium. That was enough to make gas, gravity, darkness, expansion. It was enough to make the first stars. It was not enough to make a rocky world, an iron core, a chain of carbon-rich molecules drifting through a warm ocean, or a nervous system waiting for language. For that, the universe needed repeated cycles of stellar living and stellar ruin. It needed contamination. That sounds ugly only because human language likes purity too much. In astrophysics, enrichment is often another name for productive impurity. A cloud of almost pure hydrogen and helium can make stars. A cloud seasoned by older stars can make much more. Dust grains appear, metals condense, disks around newborn stars contain a richer inventory of elements. Solid particles can collide and stick. Planetary embryos can form. Worlds with crusts, mantles, magnetic fields, atmospheres, and complex surface chemistry become possible only after earlier stars have already lived through their internal crisis and returned altered matter to space. A galaxy becomes more chemically interesting because its stars do not keep themselves. That is one of the least intuitive truths in astronomy. We are used to thinking of creation and destruction as opposites, cleanly separable. Something either builds or it breaks. Something either survives or it is consumed. But the universe has always been less emotionally cooperative than that. In the stellar story, destruction is part of the supply chain. A star must spend itself to shine, and in many cases, it must die violently to make its surroundings richer than they were before. Life will eventually depend on that violence without remembering it. Picture a supernova remnant spreading into interstellar space. Not a single neat sphere, but a turbulent shell, a collision front, a region where ejected matter plows into surrounding gas and leaves behind intricate filaments, heated plasma, shock waves, expanding asymmetries. The image can be beautiful, but beauty here is downstream of brutality. The temperatures are enormous. The velocities are extreme. Radiation floods outward. Whatever worlds once orbited too close to the dying star are not witnesses. They are casualties. And yet, from the wider galactic perspective, the remnant is not just an ending. It is a delivery system. Carbon, oxygen, silicon, magnesium, sulfur, iron, calcium, elements that will one day appear in stone, blood, teeth, seawater, continental crust, and machine parts are carried outward into the larger medium between stars. They mix imperfectly. They cool. They join clouds. Those clouds collapse again. New stars ignite. New disks form around them. In the language of astronomy, matter is recycled. In the language of lived reality, this means something harsher and more beautiful. The universe has no clean line between corpse and cradle. A future planet begins inside a past death. That is not poetry imposed on the science. It is the science, once stripped of its gentler disguises. But to understand just how severe this transformation becomes, it is not enough to follow the expelled matter outward. We also have to look at what the star fails to expel, because when a massive star dies, it does not always vanish into the explosion. Often, something remains at the center, a stellar corpse so compact, so physically extreme, that the ordinary categories of matter begin to break down. And this is where the story stops feeling merely large and starts feeling structurally alien. Take a white dwarf first, not because it is the most violent remnant, but because it shows the basic principle with unusual clarity. A white dwarf is what remains when a lower mass star sheds its outer layers and leaves behind its exposed core. It is no longer supported by ordinary thermal pressure from fusion. Fusion has effectively ended. Gravity has won most of the argument, yet collapse does not proceed forever. Something else intervenes. Electron degeneracy pressure. A quantum mechanical effect that arises because electrons cannot all be packed into the same low-energy states. Matter, stripped of its familiar spaciousness, resists further compression not through heat, but through the rules of quantum occupancy. That sentence sounds abstract. The object is not abstract. A white dwarf can contain a mass comparable to the Sun inside a volume closer to Earth's. Imagine something with the weight of a star packed into the scale of a planet. Not molten in the ordinary sense, not hollow, not gaseous in any way the phrase ball of gas could still describe, dense, exhausted, supported by the refusal of quantum mechanics to let matter be squeezed indefinitely without cost. A stellar remnant is what matter looks like after the easy options are gone. And white dwarfs are only the gentler version. If the collapsing core left behind after a supernova is more massive, gravity presses far beyond the regime where electron degeneracy can hold the line. Electrons and protons are crushed together. Neutrons dominate. What remains is a neutron star, an object with more mass than the Sun compressed into a sphere perhaps 20 kilometers across. A city-sized remnant with stellar mass. A place where matter is packed to densities comparable to those inside atomic nuclei, where a single teaspoonful of material would weigh billions of tons on Earth, where magnetic fields can become so intense that they would erase the structure of ordinary matter long before you ever came close. Again, the numbers are true, but numbers alone can deaden the imagination. Better to say it this way. A neutron star is what happens when a star's core is pressed until matter begins to resemble its own hidden skeleton. No human intuition was built for that. And yet these things are real. They spin. They pulse. Some sweep radio beams across space like lighthouses built out of collapsed matter and magnetic violence. Others sit in binary systems, stealing gas from companions, heating accretion disks until they blaze in X-rays. Some may collide with each other after eons of orbital decay, producing gravitational waves and creating conditions thought to forge many of the heaviest elements in the periodic table: gold, platinum, uranium. The universe does not manufacture such things casually. It asks for extraordinary environments. The deeper you follow stellar death, the less the universe resembles the world your senses prepared you for. And there is one more threshold. If the remaining core is massive enough, not even neutron degeneracy can maintain resistance. There is no known pressure state capable of halting collapse before an event horizon forms. The mass falls within its Schwarzschild radius. A black hole appears, not as a hole punched into space like a tunnel, but as a region where space-time has been curved so severely that all future directed paths inward remain inward. Escape ceases to be a matter of speed. It ceases to be an option built into the geometry. This is where language begins to fray in earnest. Because a black hole is not merely a very dense object, it is a boundary and causal structure, a place where the ordinary human instinct that there is always somewhere else to go stops working. The event horizon is not a surface in the usual material sense. It is more unsettling than that. It is a limit drawn into reality itself. The star that once radiated outward now leaves behind a region from which nothing radiates outward unless it was already outside. That reversal has moral force, even if physics has no use for morality. The star spent its life holding collapse off and flooding its surroundings with energy. In the most extreme ending, collapse becomes absolute enough to trap the future. And still, even here, the story is not merely destructive. Because black holes shape galaxies, neutron stars collide and enrich the cosmos. White dwarfs seed future chemistry through gentler mass loss. Supernova remnants shock surrounding gas and can trigger new waves of star formation. The death of a star is never just an obituary. It is a change in what the larger environment can become next. This is why the phrase stellar life cycle can feel too tidy if we are not careful. It suggests a neat biological arc: birth, maturity, death. But stars are less self-contained than organisms. Their endings leak into the future of everything around them. Their deaths alter the raw material of galaxies. They set the chemical stage on which later worlds will rise. They make the universe less pristine and more capable. The cosmos does not progress by staying clean. It progresses by letting its furnaces die well. And somewhere in that widening field of enriched gas and cooling dust, after enough stars have lived and failed and changed the terms, another cloud begins to gather, not pure this time, not simple, already seeded with the mineral and elemental consequences of older catastrophes. A new disk will eventually form there. New worlds will begin accreting grain by grain. A rocky planet may emerge. Oceans may condense. Chemistry may become patient enough to try something more ambitious than stone, which means the next hard truth is even more intimate than the last. Not only does life depend on dead stars, the ordinary substances of your body can be traced back through them. That sounds like a metaphor until you examine the inventory. Carbon, oxygen, calcium, iron, phosphorus, sulfur, sodium, magnesium, potassium. The words arrive to us as chemistry, as labels from a classroom wall, as ingredients listed in the neutral language of biology and geology. But those elements are not generic background substances lying around the universe in equal abundance, waiting politely to be assembled into you. Each has a history. Each had to become possible. Each belongs to a sequence of cosmic thresholds that had to be crossed long before there were cells, oceans, or planets capable of remembering any of it. Take carbon first, because without it, the conversation becomes almost unrecognizable. Carbon is not important because human beings find it romantic to say carbon-based life. It is important because its structure makes an unusual kind of chemical complexity possible. Carbon can form stable chains, rings, frameworks, branching architectures, a whole combinatorial abundance of molecules flexible enough to become metabolism, membranes, sugars, amino acids, nucleotides. But the early universe did not begin rich in carbon. Carbon had to be made, and the making was precarious. In the cores of stars that have already exhausted their central hydrogen, helium nuclei can begin fusing under far higher temperatures. But going from helium to carbon is not easy. There is no simple, direct path that makes it inevitable in a casual sense. The process depends on a narrow and remarkable nuclear circumstance known as the triple alpha process. 2 helium nuclei can briefly form beryllium-8, an unstable state that usually falls apart almost immediately. But in the hot, dense core of a star, there are enough collisions, enough chances, enough statistical persistence for a third helium nucleus to join before the intermediate state vanishes. And because carbon has an energy level unusually well suited to receive that transition, the process can proceed efficiently enough for stars to produce large amounts of it. This has been called one of the luckier-looking features of physics, though luck is only a human name for a set of values we arrived late enough to depend on. The deeper point is that carbon is not obvious. It is not guaranteed by the mere existence of matter. It appears because stellar interiors can reach a very narrow kind of productive extremity. Your chemistry begins where stellar pressure becomes selective. Then, oxygen. In the same helium-burning environments, carbon can capture another helium nucleus and become oxygen. Not every carbon nucleus does. Not every route proceeds equally. The rates matter. The balance matters. If stars turned almost all carbon into oxygen, one kind of chemistry would dominate. If they failed to produce much oxygen, another set of possibilities would narrow. The relative abundances that later shape rocks, atmospheres, oceans, and biochemistry emerge from nuclear processes that are not arbitrary but are delicate in consequence. The oxygen you breathe is not just a common gas on Earth. It is the descendant of stellar interiors finding the right pathways through energy landscapes your body will never directly witness. Then calcium, the quiet architecture in bone and teeth. Then silicon and magnesium, without which rocky planets would not look the way they do. Then iron, both geologically decisive and biologically intimate. Iron sits at the center of hemoglobin, helping blood bind and transport oxygen. It also helps define the structure of planetary cores, magnetic fields, and the internal differentiation of rocky worlds. But iron is not merely another atom in a list. In stars, iron is a turning point. The same element that becomes indispensable in blood and planet building is also the nuclear wall beyond which fusion stops paying. One of the most useful materials in the later universe is also the sign that a massive star has run out of profitable futures. The body is built from thresholds that meant different things in different places. Inside a cell, phosphorus helps carry energy and ATP, helps build membranes, helps structure DNA and RNA. Inside a dying star, the route towards such elements has nothing to do with biology. Sulfur, sodium, potassium, the same. Their role in nerve signals, protein function, fluid balance, and metabolic chemistry is local to life. Their origin is not. Their origin belongs to stellar interiors, explosive dispersal, and the long mixing of galactic material over time. This is where the phrase, "we are made of dead stars," becomes less slogan and more accounting. Not because every atom in your body came from the same kind of stellar death. The truth is more textured than that. Hydrogen in your body is ancient on a deeper timescale than the stars themselves, forged largely in the earliest moments of cosmic history. Much of the helium too, carbon, nitrogen, oxygen, and many elements up to iron were produced through stellar nucleosynthesis across generations of stars. Elements heavier than iron require environments where energy and neutron flux become more extreme. Supernova explosions contribute, and for many of the heaviest elements, neutron-star mergers appear to play a major role. The picture is not one furnace, one death, one origin. It is a supply chain of astrophysical environments. That complexity matters, because honesty matters. The grandeur of the idea does not need simplification to survive. If anything, the truth is stronger when it is allowed to stay exact. You are not made from a single poetic source. You are made from matter that has passed through multiple cosmic regimes, primordial nucleosynthesis, stellar cores, explosive deaths, violent mergers, interstellar mixing, planetary accretion, geochemical sorting, biological uptake. The body is not merely cosmic in origin, it is layered in origin. You are standing at the end of a very long materials history. And by standing, we mean something almost absurdly specific. The calcium stiffening your skeleton once required stars massive enough to move beyond simple hydrogen burning. The iron moving oxygen through your blood was forged under conditions no organism could survive. The oxygen itself, so familiar that its absence feels like emergency, is the product of ancient helium-burning interiors. The phosphorus helping cells manage energy is not a terrestrial invention. The sodium and potassium that help neurons fire their tiny electrical pulses belong to a periodic table shaped by astrophysical violence before Earth had a crust. Even the language we use to separate scales begins to fail here. We want the cosmic and the personal to occupy different emotional categories. Stars belong to the sky, blood belongs to the body, galaxies belong to distance, bone belongs to touch. But the distinction is psychological, not material. Matter does not respect the categories perception prefers. The iron in a bloodstream and the iron in a stellar core are not symbolically related. They are materially continuous across time, process, and transformation. The body is not an exception to cosmic history. It is one of its late expressions. That does not mean the body is cosmic in some vague spiritual sense. It means that if you stripped away the names and looked only at origins, your tissues would read like a record of environments far older and more extreme than anything life itself could generate. Bone is not only bone. It is a mineral archive of stellar chemistry. Blood is not only blood. It is a mobile arrangement of atoms with nuclear biographies. Breath is not only present exchange. It is a momentary borrowing of oxygen whose existence depended on stars learning how to burn helium. And yet atoms alone are not enough. That is the next pressure point, and it matters because otherwise the script would stop too early, at chemistry, mistaking ingredients for destiny. It is one thing for the universe to manufacture carbon, oxygen, silicon, iron, phosphorus. It is another thing entirely for those elements to be placed somewhere stable enough, cool enough, long-lasting enough, and structurally rich enough to become geology, atmosphere, water chemistry, and eventually life. A galaxy enriched by dead stars is still mostly hostile. Most matter never becomes a body. Most atoms never enter biology. Most planets, if they form at all, will never host oceans or cells. Enrichment expands possibility. It does not guarantee fulfillment. So, if the elements of your body trace back to stellar death, the next question becomes harder, not easier. What kind of star and what kind of world can take that inherited chemistry and keep it organized long enough for matter to attempt something as improbable as life? Because there is a difference between having the right ingredients and having a workable kitchen. There is a difference between a universe capable of complexity in principle and a local environment capable of preserving complexity against entropy long enough for it to elaborate itself. Carbon alone does not make a cell. Oxygen alone does not make an ecosystem. Iron alone does not make circulation. The periodic table can be rich while the world remains sterile. Life needs matter, yes, but it also needs patience from a star. Patience is one of the least dramatic words in science. It sounds mild, domestic, almost sentimental, but in astrophysics, patience is an achievement. A star must hold itself in a narrow and costly balance for spans of time so immense that human history disappears inside them. It must radiate steadily enough for temperatures on a nearby world to avoid catastrophic swings. It must not erupt too violently, not fade too soon, not spend itself with the extravagance of the massive blue stars, not cling to such feeble output that habitable conditions become vanishingly difficult, or are constantly assaulted by flares. To produce the ingredients of life is one thing. To provide a usable stage for life is another. This is where the emotional center of the story starts to move inward. Until now, the stars have been distant engines, manufacturers of chemistry, destroyers that enrich the dark. But the fact that your body contains their products is still only half the truth. Matter can be rich and remain dead forever. A universe can contain carbon and never produce a song, a memory, a language, a fear of death, a hand reaching towards sunlight. What closes that distance is not merely composition, it is sustained disequilibrium. A world needs a long-running energy gradient. It needs a constant flow. It needs a star willing to keep doing the same astonishing thing every day for absurdly long stretches of time. Life is not built from atoms alone. It is built from atoms under management. That management begins with the kind of star at the center of the system. Massive stars are magnificent in the way storms are magnificent, brilliant, forceful, brief, and disastrous for anything hoping to build slowly. Their ultraviolet radiation can be ferocious. Their winds can strip nearby environments. Their lifetimes are too short for the gradual, patient elaboration of complex biology as we know it. They live in the key of spectacle. That is not what life needs. At the other end are red dwarfs, the quiet misers of the cosmos. They are by far the most common stars in the Milky Way, small, cool, and efficient. They can burn for trillions of years, far longer than the current age of the universe. In one sense, they are the masters of patience. Yet many of them create a different problem. Their habitable zones lie close in, so close that planets there may become tidally locked, with one hemisphere facing the star permanently. Many young red dwarfs are also flare-active, releasing bursts of radiation capable of challenging atmospheres and surface chemistry. This does not rule out life around them. The science is still open, and nature has surprised us before. But it does complicate the picture. Longevity alone is not enough. Stability has texture. So, the kind of star that nurtured life on Earth does not sit at either extreme. The Sun is not the largest to brightest, hottest, or longest-lived star. It is not a cosmic celebrity. It is a G-type main-sequence star, ordinary in the astronomical sense, which turns out to be almost miraculous in the biological sense. Ordinary enough to last billions of years, bright enough to sustain liquid water at the right distance, stable enough that climate could persist inside a relatively narrow thermal regime for geologically meaningful spans, quiet enough, most of the time, to let chemistry become ecology without being continuously reset by stellar violence. The Sun is not important because it is rare. It is important because it was calm enough to be forgotten. That may be the strangest compliment physics can pay. We do not wake each morning astonished that the sun rose with approximately the same luminosity as yesterday. We have converted one of the most extraordinary long-running acts in the local universe into background. Its steadiness became part of the silence in which life learned to breathe, divide, adapt, and eventually think. If the sun behaved with the volatility of many younger or smaller stars, or died with the impatience of a massive one, Earth's story would not merely look different. It might never have advanced past chemistry at all. This is the harder truth behind the old romance of stardust. We like to say life comes from the stars, and that is true, but the phrase hides the double requirement. A past generation of stars had to die to make the elements. A present star had to live well enough to make those elements useful. Life needs ancestors and a caretaker. Even then, the odds do not become generous. Planetary systems are chaotic in detail. Gas giants migrate, small worlds collide, atmospheres are lost, volatiles are delivered or withheld, magnetic fields appear, decay, or fail to form. A planet may sit in a nominally habitable zone and still become sterile. It may have water and lose it. It may keep oceans and never cross the threshold into biology. The path from enriched dust to conscious organism is not one process. It is a stack of precarious permissions. First, there must be enough heavy elements in the natal cloud for rocky planets to form at all. Astronomers use the word metals in a way that would puzzle a chemist. Anything heavier than helium counts. Metallicity matters because without enough of those heavier elements, protoplanetary disks do not have the same capacity to produce terrestrial worlds with complex mineralogy. Then comes the architecture of the disk itself, the collisions and accretion that turn grains into pebbles, pebbles into planetesimals, planetesimals into worlds. Then the long violence of impacts, differentiation, outgassing, atmospheric development, water delivery, tectonic possibility. Then the still unresolved crossing from rich chemistry into life. At every stage, the star remains central, not merely as a lamp, but as a regulator, too dim, and water freezes out or exists only under narrow conditions, too bright, and runaway greenhouse processes threaten, too unstable, and atmospheres suffer repeated assault, too brief, and evolution runs out of time. A star is not just a source of light for life. It is part of life's temporal budget. That budget is one of the most underappreciated facts in the universe. Evolution on Earth did not sprint from chemistry to civilization. It moved with almost unbearable slowness when measured against a human lifetime. Single-celled life dominated for most of our planet's history. Complex multicellular organisms arrived late. Brains capable of abstract thought arrived late. Technological civilization arrived so late that it looks like a flicker against geological time. For all of that to happen, Earth required not a dramatic star, but a dependable one. Not a burst of abundance, but a platform, not spectacle, but continuity. A star willing to behave for a very long time. This changes the meaning of sunlight. Sunlight is easy to domesticate in the mind. It warms skin, powers weather, drives photosynthesis, casts shadows, marks time. It feels immediate, practical, local, but each beam that reaches the ground is the end of a process that began in the sun's core, where hydrogen nuclei fused under crushing pressure, releasing energy that wandered outward through dense stellar matter for vast spans before finally escaping the surface and crossing space. The warmth on a leaf, the energy stored in sugar, the oxygen later released, the animal later eating that plant, the brain later using that oxygen and glucose to think. All of it belongs to an unbroken causal chain, connecting nuclear reactions in a star to biochemistry on a planet. The distance between fusion and thought is not metaphorical. It is ecological. This is where the body becomes impossible to see as merely local. The atoms were inherited from dead stars. The usable flow of energy came from a living one. The calcium in bone and the oxygen carried by blood came from astrophysical history. The metabolic work of those tissues depends on present solar input, whether directly or through the ancient stored sunlight of food webs and fossil carbon. You are made from stellar remains, and you are animated within stellar allowance. That is a colder, more exact statement than "we are stardust." And it has more force because it leaves less room for sentimentality. Stardust sounds passive, as if the cosmos simply sprinkled itself into living form. The real story is harsher. The ingredients had to be forged under extraordinary conditions, scattered by violence, reassembled into a planetary system, organized by geology, and then held in a narrow thermodynamic corridor by a star stable enough to avoid destroying its own possibilities. Life is what happens when stellar violence is followed by stellar restraint. That sentence matters because it marks the true midpoint of the descent. Until now, the story could still be heard as one long act of cosmic generosity. Stars make things. Stars enrich galaxies. Stars provide light. The universe begins to sound almost nurturing if the language is not watched carefully enough. But nurturing is the wrong word. Nothing here was arranged for life. Nothing was tuned around our preferences. The same sun whose steadiness made Earth livable will also grow brighter over time, altering the planet's climate beyond habitability long before its final red giant phase. The same stellar processes that made worlds possible also impose expiration dates. The stage is never permanent. That is another illusion worth breaking now before the story deepens further. We tend to speak of habitable planets as if habitability were a property like mass or composition, something a world simply has. But habitability is dynamic. It is a moving interval, a negotiated state, vulnerable to stellar evolution, atmospheric change, geologic cycles, orbital shifts, impacts, and internal planetary history. Earth itself has remained habitable only by passing through countless contingencies, feedbacks, and partial recoveries. Its climate has swung wildly. Its atmosphere has transformed. Most species that ever lived here are gone. Stability, once again, turns out to mean managed crisis, not peace. That pattern repeats from stars to planets to life itself. Perhaps that is why the story has weight. The same structure keeps reappearing at larger and smaller scales. Things that matter endure by living inside narrow windows between collapse and excess. Stars do, climates do, biospheres do, civilizations do. The universe is not built around comfort. It is built around temporary balances that can, under the right conditions, become astonishingly productive before they fail. And there is still one more fracture waiting in the sky. Because even after you understand that stars are not fires, that their deaths made your atoms possible, and that your living world depends on the prolonged restraint of one particular star, the night above you remains easy to misread in another way. It still feels present. It still feels like a scene occurring now. But starlight is older than the moment in which you receive it, and the farther you look, the less the sky resembles a place, and the more it resembles a time archive. The stars do not appear to you in the present. They arrive as history. That changes the emotional geometry of the sky once again. By day, the sun dominates so completely that it persuades you of immediacy. Light pours across walls, skin, leaves, pavement, shadows move, heat accumulates on stone. Everything feels synchronized with the present tense. The source seems current because its effects are current. But even sunlight is delayed. Photons take a little more than 8 minutes to cross the distance from the sun to Earth, and the energy they carry began its story far earlier than that, buried in the solar interior long before it escaped the surface. The warmth feels instantaneous only because the human nervous system was never designed to notice the long history hidden inside a beam. At night, that hidden history becomes harder to ignore. The nearest star beyond the sun, Proxima Centauri, is a little over 4 light-years away. When its light reaches you, it is already more than 4 years old. Sirius, one of the brightest stars in our sky, appears as it was more than 8 years ago. Vega, about 25, Betelgeuse, hundreds. The Andromeda Galaxy, visible to the unaided eye under dark skies, is seen as it was more than 2 million years in the past, long before human civilization, long before cities, before writing, before agriculture, before our species had become what we now think of as ourselves. The night sky is not a present scene. It is a layered arrival of different pasts. That is not a poetic exaggeration. It is the plain geometry of light moving at a finite speed through a large universe. But facts do not remain plain once you let them touch intuition. Because the old picture of the stars, tiny points pinned to a single dome above the Earth, was wrong not just in scale, but in time. We do not see the sky all at once in a common now. We see it as a collage assembled from different distances, which means different ages, which means the apparent unity of the night is an illusion produced inside the observer. The darkness overhead is a time mosaic, and the more distant the source, the more radical the delay becomes. Look at a galaxy tens of millions of light years away, and you are seeing light that left before the human genus had taken its current form. Look billions of light years out, and the familiar architecture of the cosmos begins to unspool into younger and younger stages. Galaxies appear less settled. Star formation rates change. The large-scale history of the universe starts to reveal itself, not because the cosmos has preserved a museum for us, but because light has taken so long to arrive that distance and time become inseparable. Space is how the past reaches you. This is one of those truths that sounds manageable when phrased once and then keeps getting stranger the longer it remains in the mind, because it means that every glance upward is not only an outward look, but a backward one. You are not standing beneath a ceiling of simultaneous objects. You are standing inside a flow of delayed information. The stars you see tonight are not lined up in a single moment waiting to be admired. They are sending reports from different eras, and your brain, which evolved to navigate prey, shelter, faces, and weather, compresses all of it into a simple visual field. Human perception edits the universe into coherence. Physics does not. That matters because it reveals a pattern larger than starlight itself. Again and again. Reality turns out not to be what it first feels like. Solid matter is mostly empty space structured by fields and quantum rules. A star is not a fire, but a prolonged resistance to collapse. Stability is often negotiated crisis. And now the sky itself, the oldest symbol of permanence, is not a present object, but a stream of delayed evidence. The deeper we go, the less comfort intuition can offer. Even now begins to thin out under this pressure. Not in the sensational sense that time is unreal, or that physics dissolves experience into nonsense. Everyday time remains good enough for crossing a street, breathing a breath, holding a conversation. But the cosmic picture is less forgiving. There is no universal presence spreading cleanly across the stars for you to observe. Relativity has already warned us that simultaneity is not absolute in the way instinct wants it to be. Add the finite speed of light, and the visible sky becomes something even more unsettling. Not a direct window onto what exists at this moment elsewhere, but a patchwork of messages sent under different conditions from different depths of time. You never see a star in the present. You see the star's successful past. Or, in some cases, you see a past the star itself has already outgrown. This is not merely theoretical unease. There are real objects whose current state may differ from what the night still shows us. Betelgeuse offers a softened version of the problem. It is a red supergiant, unstable, evolved, and expected to end its life in a supernova on astronomical timescales. That does not mean it is about to explode in any humanly predictive sense. Soon, in astrophysics, can mean anything from tomorrow to 100,000 years from now. Responsible science has to remain disciplined there. But because the star is hundreds of light years away, whatever has happened there recently, by our standards, has not necessarily reached us yet. One day, if the supernova occurs within the relevant window before its light arrives, the sky will appear to change suddenly. Yet the event itself will already belong to the past by the time human eyes register it. The spectacle, if it comes, will not be current. It will be delivered. That is true of everything in the sky, from nearby stars to distant galaxies. Astronomy is not the observation of remote objects in their immediate condition. It is the interpretation of late signals. Telescopes do not bring us closer in the way a microscope brings a cell into view. They deepen our access to delay. They let us collect older and fainter light, and therefore reconstruct structures and events farther removed from the present moment in which we do the observing. Astronomy is what knowledge looks like when the evidence cannot arrive on time. There is something severe in that. The science becomes more powerful, not less, precisely because it accepts the delay and learns how to reason through it. Spectra reveal composition. Luminosity and temperature reveal stellar classes and life stages. Light curves reveal orbital companions, pulsations, explosions, accretion, rotation. Redshift reveals cosmic expansion. Gravitational waves now add a second medium of report, carrying the signatures of mergers and extreme events through space-time itself. The universe does not become understandable by becoming immediate. It becomes understandable because physics gives us lawful traces, and because patient minds learn how to read traces without mistaking them for presence. That discipline should matter to the tone of the story too. Because once you understand the sky as delayed evidence, the old sentimental picture of personal cosmic intimacy starts to sharpen into something less flattering and more exact. We are not gazing directly into the living face of the universe. We are reconstructing it from emissions already in flight. We do not meet the cosmos on equal terms. We infer it. We receive it. We assemble it from fragments that arrive too late to ever be called direct. And yet that distance does not empty the experience of wonder. It gives wonder a harder spine. A beam of starlight crossing space for years, centuries, millennia, or millions of years before dying on a retina is not less astonishing because it is delayed. It is more astonishing because the delay is part of the truth. The sky is not meaningful despite its distance and lateness. Its distance and lateness are the meaning. The stars teach us. If we let them, that reality does not arrange itself for immediate comprehension. It becomes visible only through endurance, on the side of the light, and on the side of the mind trying to receive it. To look up, then, is to stand inside a strange arrangement of inheritance. The atoms in your body come from old stars. The sunlight feeding Earth comes from a present star whose energy has its own buried past. The night beyond it reaches you as a stratified archive of vanished moments. You are built from stellar history, sustained by stellar process, and informed by stellar delay. Even your knowledge of the cosmos depends on signals that had to survive their journey longer than any human project ever has. That makes the familiar phrase "under the stars" feel subtly wrong. You are not simply under them. You are downstream of them. Downstream of their chemistry, downstream of their stability, downstream of their deaths, downstream of the light they released long before you asked what any of it meant. The sky above is less like a ceiling than a current, one carrying energy, matter, and information from older states of the universe into this present arrangement of flesh and thought. And currents imply direction. Which brings us to the next, more difficult truth. The stellar age itself, the age in which stars are abundant, galaxies still produce them in large numbers, and worlds like ours can inherit both their elements and their energy, is not the permanent condition of the cosmos. It feels normal only because it is the only era any human has ever known. But stars are not eternal, and neither is the age of burning things. We happen to live while the furnaces are still on. That fact is easy to hear and hard to feel, because human beings are born into a universe already lit, already structured, already populated by stars so numerous that darkness seems like the exception rather than the rule. We inherit a sky in which stellar light feels normal. Galaxies shimmer with it. Nebulae glow around it. Planets orbit within it. Biology depends on it so completely that thought itself becomes difficult to imagine without some long continuity of solar input, somewhere behind the chain of causes. We do not experience the stellar age as a phase. We experience it as reality. But it is a phase. The universe has not always looked like this, and it will not look like this forever. There was a time before stars. That is the first correction. After the Big Bang, the universe expanded, cooled, and spent a long interval with no stellar light at all. Hydrogen and helium filled the dark. Matter clumped gradually under gravity. The first stars had not yet formed. No galaxies in their mature forms. No planets. No chemistry rich enough for rock, much less life. only the slow growth of structure inside a universe still young enough to be relatively simple. Cosmologists sometimes call part of that interval the cosmic dark ages. And the phrase earns its weight, not because nothing existed, but because the kinds of luminous complexity we instinctively associate with the universe had not yet begun. Then gravity thickened the dark. The first stars ignited. They were probably unlike the sun in important ways, massive, short-lived, born from primordial gas untouched by earlier enrichment. They altered their surroundings dramatically, flooding space with radiation, beginning the long process of reionization, creating the first heavy elements, seeding the next generations with more complicated material than the universe had previously possessed. In that sense, the stellar age was not just a chapter added onto an already complete cosmos. It was the beginning of a new kind of possibility. Before stars, the universe had mass and law and expansion. With stars, it gained furnaces, chemistry, planets, and eventually witnesses. We are creatures of that transition, not merely because stars exist now, but because enough generations of them have already lived and died to make a world like Earth chemically feasible. Our planet formed roughly 4.5 billion years ago, from a protoplanetary disk already enriched by earlier stellar cycles. The Sun itself is not a first-generation star. It belongs to a later universe, one already seasoned by previous catastrophes. That means the light-warming Earth today is part of an era already mature enough to remember older stars in its composition. The Sun is not the beginning of the story. It is a late inheritor inside a universe that had already been altered many times before it arrived. And alteration continues, but not symmetrically. Galaxies do not produce stars forever at the same rate. Over cosmic time, the available reservoirs of cold gas are depleted, heated, dispersed, or locked up. Mergers reshape systems. Feedback from stars and active galactic nuclei stirs and expels material. Star formation rises, peaks, declines. The universe is still making stars, but not with the youthful abundance it once did. In the Milky Way and beyond, the broad trend is downward. The great era of rampant stellar production lies behind us more than ahead of us, which means the sky we inherit is already somewhat late. Not late in the melodramatic sense, not a dying cosmos on the verge of sudden silence. There are still vast numbers of stars, and many trillions of years remain for the dimmest, most patient ones, but late enough that the universe's brightest season of star formation has already passed. The cosmic noon of galaxy growth and stellar birth occurred billions of years ago. We live after that peak, in a universe that still glows intensely by human standards, but is no longer at the height of its reproductive force. The furnaces are still on, but the abundance that once fed them is not infinite. This matters because it changes what normal means. The present sky feels timeless only because our lives are too short to register the slow decline. Yet, on larger timescales, the stellar era has structure. It has an opening, a flourishing, and a thinning out. Massive stars live fast and vanish early. Sun-like stars endure for billions of years. Red dwarfs, the smallest and most frugal, may continue burning for trillions. Long after stars like the Sun are gone, the universe may still contain those dim red embers. They will not blaze magnificently. They will persist, quietly, economically. A far future cosmos may be lit less by brilliance than by endurance. That future is difficult to picture because it strips the night of the kinds of lights our eyes and myths were trained on. No bright blue giants, no fresh star-forming abundance on the old scale, fewer spectacular deaths, more long-lived remnants, more darkness between acts. The age of easy fire will slowly contract into an age of dwindling embers. And after even those go out, the story becomes colder still. White dwarfs cool, neutron stars lose energy, black holes dominate certain regions of galactic structure. The mechanisms by which the universe once generated visible splendor become less common, then rare, then absent. Speculative details remain at the far end of physics here, and responsible language has to keep that boundary clear. Exactly how the unimaginably remote future unfolds depends on the behavior of matter, expansion, black hole evaporation, and deep cosmological questions that are not all settled in lived detail. But the broad trajectory is robust. The universe is not moving toward more stars forever. It is moving toward fewer opportunities for fresh, luminous complexity. We live in the interval when light is still affordable. That line is not sentimental. It is thermodynamic. Stars are engines that turn gravitational concentration and nuclear structure into ordered flows of energy. Life exploits those flows. Climate depends on them. Photosynthesis depends on them. Chemistry far from equilibrium depends on them. But stars are not the default state of matter. They are temporary arrangements. To live in an age full of them is therefore to live during a special interval in cosmic history. Special not because it was chosen, but because it is bounded. The universe can spend only so much simplicity turning it into structure. That is another way of saying that stellar abundance is a budget, not a promise. Matter gathers, ignites, burns, enriches, disperses. Some of it gathers again. The process is grand, but not inexhaustible. And because everything we have been tracing, your atoms, Earth's geology, the sun's long steadiness, the visible night, the very possibility of biological and intellectual complexity, depends on the existence of stars in sufficient number and suitable kind. Our existence belongs not merely to the universe in general, but to a particular era in the universe's history. Not the beginning, not the end, the bright middle. That phrase should carry more unease than comfort, because middles are where things feel most natural while already containing their own disappearance. A child born into summer may mistake green for permanence. A civilization living through a stable climate may call that stability normal. A species arising during the stellar era may look up and think stars are simply what reality is made of. But normality is often only local persistence mistaken for law. The sky is old enough to mislead you. Everywhere in this story, the same lesson returns under different disguises. The star that looks still is a violent negotiation. The atom in your blood that feels ordinary required astrophysical extremity. The sunlight that seems immediate is delayed. The night that looks present is archival. The age that feels universal is temporary. Again and again, reality withdraws from the first interpretation and reappears at a deeper, less comforting level. That is not an argument against wonder. It is an argument against easy wonder. Easy wonder is impressed by scale. Harder wonder is altered by structure. And the structure here is severe. We happen to exist in a universe old enough for many generations of stars to have enriched it, but young enough that stars still fill the dark in immense numbers. We arrived after enough death for chemistry, but before the long fading of the fires, we are late enough to inherit complexity and early enough to inherit light. We were born early enough to inherit fire. That is not a poetic flourish. It is a historical statement about the cosmos. And once you see it that way, the phrase made of dead stars stops sounding like a loose expression of cosmic kinship and begins to sharpen into a more exact claim. You are not simply composed of stellar remnants in some broad symbolic sense. You are the product of living in a universe where several conditions overlapped at once. Earlier stars had already died. Later stars still existed. One local star remained stable long enough. One local planet remained workable long enough, and matter had not yet lost the thermodynamic room required for complexity to persist. In other words, your existence is not only material inheritance, it is timing. Timing at the level of galaxies, timing at the level of star formation, timing at the level of planetary stability, timing at the level of evolutionary patience, timing so vast that human language almost cannot hold it without collapsing back into metaphor. But the truth survives even when language strains. This moment in which matter can look up and ask where its atoms came from is not guaranteed by the universe as a whole. It is allowed by a temporary arrangement of cosmic history. And that makes the final return to the body heavier than before. Because now the body is not just made of stellar products. It is made of them during the brief era in which such products can still be assembled, energized, cooled, circulated, metabolized, remembered. Flesh is not simply recycled astrophysics. It is recycled astrophysics granted a narrow historical window in which organization remains possible. The body is what stellar history looks like while the lights are still on, which means the last task is to return to the opening illusion and strip it cleanly of its softness. The old phrase still contains truth, but not enough of it. We are not made of some gentle cosmic dust floating romantically down from heaven. We are made from matter that passed through stellar interiors, stellar failures, galactic mixing, planetary violence, geological sorting, biological risk, and a temporary age of burning things. The sky above you is not merely beautiful. It is ancestral, temporary, and already receding. And that is why the phrase has to be said more carefully now. Not we are stardust. Not even we are made of stars, at least not if the sentence is allowed to remain soft around the edges. The more exact statement is harsher. We are made of matter that stars processed, and of conditions stars temporarily made available. The difference matters, because stardust can be heard as romance. It sounds weightless, decorative, a little veil of cosmic powder settling gently over life. But nothing in the actual chain of events was gentle. Not the crushing interiors of stars, not the supernovae that dispersed enriched matter into the galaxy, not the impacts that helped assemble planets, not the geologic instability of the early Earth, not the billions of years during which evolution kept failing, restarting, branching, and dying back before one small lineage learned how to ask where it came from. The truth is not lighter than the slogan. It is heavier. And once the heaviness is allowed in, the body changes character. It stops feeling like a purely biological object and begins to look like a temporary arrangement of materials with very old permissions. Skin, blood, bone, nerve tissue, the calcium crystals in teeth, the iron moving oxygen, the phosphorus helping cells transfer energy, the carbon lattice behind every complex organic molecule. None of it is self-originating. None of it belongs fully to the narrow present in which you happen to inhabit it. The body is a late experiment performed with ancient inventory. That does not make it less intimate. It makes it stranger. Because intimacy usually depends on the feeling of nearness. My body is near. My pulse is near. Breath is near. Pain is near. Hunger. Fatigue. Warmth. Memory. Near. Stars belong to the opposite category. They are what distance looks like. They are what remoteness looks like. The mind likes the separation because it preserves scale. There is the human world here. There is the cosmic world out there. One is immediate, vulnerable, small. The other is vast, cold, and mostly irrelevant to ordinary life. But the separation is psychological, not material. The material continuity is absolute. It runs from stellar cores to interstellar clouds, from clouds to disks, from disks to planets, from planetary chemistry to living cells, from cells to nervous systems, from nervous systems to self-consciousness. The distance is real in space and time. It is not real in substance. The atom does not care whether you assign its earlier life to astronomy and its current life to biology. It only passes from one lawful arrangement to another. That means the body is not simply in the universe. It is one of the ways the universe keeps going. Again, that line should not be allowed to become vague. It does not mean the universe somehow wanted consciousness, or arranged itself with human beings as an endpoint. The science supports no such vanity. Most of the cosmos remains sterile as far as we know. Most matter never enters life. Most stars shine on nothing that can witness them. The scale of indifference remains immense. But indifference is not the same as disconnection. You are not the goal of stellar history. You are one of its byproducts, a rare and local one, perhaps, but materially continuous all the same. And continuity changes the emotional charge of ordinary acts. Take breathing. It feels so immediate that it almost resists interpretation. Air enters. The lungs receive it. Oxygen crosses into blood. Cells use it to extract energy from food. Carbon dioxide leaves. The act is intimate, repetitive, biological. But the oxygen itself has a longer biography than the breath that carries it. On Earth, its free abundance in the atmosphere depends on life, on photosynthetic organisms that reshape the planet over deep time. Yet, The oxygen atom as an element, the reason such an atom exists at all, reaches back beyond Earth, beyond biology, into stellar helium burning inside older stars. One breath is local. The element enabling it is not. Or take blood. It feels warm, animal, alive in the most immediate way. But hemoglobin's ability to bind oxygen depends on iron. And iron is not just another ingredient. Iron is a stellar turning point. The element that helps vertebrate bodies move oxygen is the same element that marks the fatal limit in the core of a massive star. In one context, it sustains life. In another, it signals the end of a star's ability to support itself through fusion. The same nucleus moves between dramas without knowing the difference. The body is built from matter that has already served other endings. Bone carries a similar severity. Calcium helps form the mineral structure that gives skeletons strength. Touch a wrist, a jaw, a rib, and the experience feels immediate, terrestrial, anatomical. Yet calcium, like so much else in the periodic table beyond the lightest elements, required stars and stellar deaths to become widespread in the cosmos. The hard architecture under flesh is not native to Earth alone. It is imported possibility, locked into organisms after a much older astrophysical prehistory. Even sunlight, which seems like the most present thing in the world, is implicated twice over. First, as current energy, the sun's fusion supports climate, ecology, and photosynthesis. Second is ancestry. The materials of Earth and life were inherited from earlier stars, whose deaths enriched the cloud that formed the solar system. We live under one star while being built from others. Present support, ancient inheritance, a living furnace overhead, dead furnaces behind us. That layered dependence is easy to say and difficult to hold emotionally. The mind keeps trying to simplify it into a single image, a poetic slogan, a clean statement of belonging. But belonging is too warm a word unless it is disciplined by structure. The universe did not gather itself into stars for our sake, then arrange one stable solar system so that eventually we could stand in a field and feel connected. What happened is less flattering and more awe-inspiring under the lawful behavior of gravity, quantum mechanics, thermodynamics, and nuclear physics. Matter passed through a series of transformations severe enough to make complexity possible, and one small region of that complexity became capable of recognizing the chain. Recognition is not the center of the story. It is its late after effect. That is why this descent has been moving steadily away from comfort, not because comfort is forbidden, but because the real dignity of science lies in refusing false softness. The truth is already beautiful enough. It does not need to be padded. The stars are not wonderful because they flatter us. They are wonderful because they make no emotional concessions and still, under those indifferent laws, leave room for worlds, chemistry, weather, oceans, cells, and thought. The universe never promised anything so intricate. It merely allowed for a while. And that phrase returns us to the narrower, harder edge of the body itself. Because a body is not only composed of old matter, it is composed of old matter held briefly in organized defiance. Cells maintain gradients. Membranes preserve boundaries. DNA stores instructions. Proteins fold and unfold. Neurons sustain electrical differences and release neurotransmitters across tiny gaps. Heat is regulated, damage is repaired. Entropy is pushed back locally by constant work. In that sense, life is not the opposite of the stellar story. It is a continuation of one of its deepest themes: temporary balance against collapse. Stars do it with gravity and fusion. Planets do it with climate and internal dynamics. Organisms do it with metabolism and repair. Ecosystems do it with cycles of energy and matter. Civilizations do it with agriculture, infrastructure, memory, and law, again and again. What matters exists inside narrow windows where structure can hold for a time without becoming permanent. The universe does not make permanence. It makes intervals. That may be the most adult form of the idea we began with. Not simply that we come from stars, but that stars themselves belong to a larger pattern in which structure is borrowed, not owned. A star borrows its long equilibrium from fuel. A planet borrows habitability from a workable balance of radiation, atmosphere, chemistry, and time. A body borrows coherence from metabolism. Consciousness borrows duration from a brain's continual maintenance of fragile physical states. Everything luminous, living, or meaningful is downstream of conditions that can fail. And yet failure is not a reason to dismiss the interval. It is the reason the interval has value. A star's life matters because it is finite. A habitable planet matters because it is contingent. A living body matters because it is a brief arrangement that did not have to happen and will not happen forever. Meaning, if the universe allows such a word at all, enters not in spite of transience, but through it. The stars are not diminished by being temporary, they become legible through their temporariness, their violence, their restraint, their chemistry, their deaths, their remnants, their light arriving late. All of it belongs to a universe where durability is always conditional. So, when you say or hear that you are made of dead stars, the sentence should no longer feel merely uplifting. It should feel exacting. It should carry the pressure of everything required to make it true. Not just exploding suns, but quantum tunneling, iron limits, galactic mixing, planetary formation, biological risk, and a historical window in which stars still burn brightly enough for life to feed on their energy while inheriting the matter of older generations. You are not the child of a calm cosmos. You are the current arrangement of a violent inheritance. And that inheritance is still visible if you learn how to read the ordinary world correctly, in blood, in bone, in breath, in the warmth of daylight on skin, in the mineral content of rock, in the oxygenation of an atmosphere, in the very existence of a habitable planet orbiting a relatively stable star. The cosmic is not elsewhere. It is local now, condensed into physiology and weather and geology so thoroughly that we no longer notice its origin. Which is why the sky has to be returned to one last time, but differently than before, not as scenery, not as inspiration, as context. Those lights above are not remote ornaments floating safely outside the human story. They are part of the material precondition of every human story that will ever be told. The distance remains real. The causal intimacy remains real too, both at once. That doubleness is what makes the truth so difficult to internalize without simplifying it into cliché. The stars are far away. Their consequences are under your skin. And once those two lines can coexist in the same mind without collapsing into sentiment or abstraction, the next question becomes unavoidable. If the body is a temporary arrangement of violent inheritance, and if the stellar age itself is temporary, then what exactly is a human life inside that chain? What does it mean for matter forged in ancient catastrophe to become conscious only briefly, here, in this narrowing age of light? It means, first, that consciousness is not outside the story. That may sound obvious, but the mind resists it in subtle ways. We are very good at admitting that the body is physical and then quietly treating awareness as if it arrived from somewhere else, something cleaner, later, less compromised by matter. Thought feels unlike stone. Memory feels unlike metal. Fear, love, grief, anticipation, language, all of it feels so interior, so immediate, that it tempts us to imagine a clean break between the chemistry of the world and the private brightness of experience. Even people who reject supernatural explanations often preserve a softer version of the divide. Matter over here, mind over there. At some point, the universe became conscious. Yes, but surely consciousness is a new category now, something that no longer really belongs to the same severe history as stars and collapse and fusion. But it does. A thought is not less physical because it is intimate. A memory is not less material because it is invisible. Every perception you have depends on electrochemical gradients sustained across membranes, on ions moving through channels, on neurotransmitters crossing synapses, on proteins folded into improbable usefulness, on oxygen delivered to tissue that cannot go long without it, on glucose or other metabolic fuels being processed fast enough to maintain the unstable order we call a living brain. The brain feels nothing like a star from the inside, yet, in a stricter sense, it belongs to the same family of phenomena, a temporary structure holding itself away from collapse by means of continuous throughput. Not the same mechanism, the same grammar. That is the deeper continuity. Stars resist gravitational collapse through pressure generated by fusion. Living systems resist thermodynamic flattening through metabolism, repair, and exchange. A star persists by spending its fuel. A cell persists by spending its gradients. A brain persists by maintaining an exquisite pattern of controlled instability. Shut off the energy flow, and the structure does not merely dim. It begins to fail as the conditions required for its order disappear. Consciousness is not what escapes matter. It is one of the things matter can do, while enough energy is passing through it. That sentence should land with more force than any easy cosmic slogan, because it is both less flattering and more astonishing. Less flattering, because it does not place the human mind outside the lawful severity of the universe. More astonishing, because it means that ancient stellar processes did not merely produce atoms, worlds, and climates. Under the right chain of conditions, they help produce a form of organized matter capable of reflecting on its own origin. Not because reflection was inevitable, not because the cosmos was aiming toward it, simply because once the right materials, environments, timescales, and energy flows coincided, the universe discovered that it could, in one small place, become self-interpreting. That is a very different claim from saying the universe wanted to know itself. Science does not need that vanity. What it can responsibly say is stranger and cleaner, the same laws that allow stars to ignite, evolve, collapse, and enrich their surroundings also allow chemistry, under suitable planetary conditions, to become biology. Biology, under further conditions, to become nervous systems, and nervous systems, under still narrower conditions, to become conscious enough to ask what any of this is. No law is broken in the transition. No supernatural exemption is required. The mystery does not disappear. It changes level. The question stops being, how could mind be made of matter, and becomes, what must matter be like for mind to ever arise from it? And now the earlier parts of the story return under a new light. The carbon in neural tissue is not generic carbon. The phosphorus involved in cellular energy transfer is not generic phosphorus. The sodium and potassium that help produce action potentials across neuronal membranes are not generic salts. Every mental act depends on materials with astrophysical biographies. The brain is not merely housed in a cosmic universe. It is built from elements whose existence required stars, and it operates only because present solar energy, directly or indirectly through planetary ecology, remains available to sustain the biosphere that supports it. A thought is not made of starlight, but it is impossible without stellar history. That distinction matters because it protects the idea from becoming mushy. There is a temptation, once the script reaches consciousness, to drift into vague metaphysical fog. The stars became us. The cosmos awakened. The universe is dreaming through human eyes. Such lines can sound elevated while actually weakening the truth. The truth is more disciplined than that. Stars did not become you in any simple narrative sense. Vast chains of contingent physical processes intervened: galactic enrichment, solar system formation, geochemistry, abiogenesis, evolution, extinctions, ecological bottlenecks, primate cognition, language, culture. The root is too jagged, too local, too contingent to flatten into destiny. And yet flattening it would also miss something real. Because contingency does not erase continuity, it sharpens it. The fact that the path is improbable makes the result more startling, not less. Matter that once sat in stellar interiors, or in the debris fields of their deaths, now participates in circuits that generate first-person experience. That is not a mystical statement. It is a physically grounded one. The atoms do not stop being atoms when arranged into a cortex. The fact that cortex feels unlike rock tells you something not about supernatural interruption, but about the extraordinary difference organization makes. This is one of the oldest and hardest lessons in science. Arrangement matters as much as inventory. Hydrogen and oxygen can become water, but not by existing separately. Carbon can become graphite or diamond depending on structure. The same nucleotides can sit inert in a laboratory vial or function inside a living genome depending on context, arrangement, and history. Likewise, the elements inherited from stars do not become mind merely by being present in a body. They become capable of participating in mind when assembled into a system with enough complexity, energy flow, memory, and recursive modeling to produce awareness. The wonder is not in the atoms alone. It is in what lawful arrangements of atoms can sustain. And lawful arrangement is always temporary. That theme has been tightening around us from the beginning. A star is a balance that spends itself. A habitable planet is a balance that can drift, fail, or recover for a while. A biosphere is a balance of energy capture, nutrient cycles, atmospheric chemistry, and ecological interdependence. A body is a balance of repair and breakdown. A mind is a balance of ongoing neural activity. Everything we care about appears, holds, transforms, and eventually yields. The pattern is not depressing because it ends. It is severe because ending was built in from the start, which makes human consciousness stranger than simple cosmic optimism allows. We are often tempted to use the language of insignificance here. The universe is vast, we are small, therefore our lives are negligible. There is a kind of truth in the scale comparison, but it becomes lazy if left there. Small is not the same as unimportant. Brief is not the same as meaningless. Rare is not the same as trivial. In a universe mostly filled with sterile matter, extreme heat, vacuum, radiation, and darkness. The emergence of organisms capable of building internal worlds, storing memories, making art, suffering loss, and reconstructing stellar history is not cosmically central, but neither is it nothing. It is one of the most intricate states matter is known to achieve, not the purpose of the universe, one of its sharpest local consequences. That phrase protects the scale while preserving the force. Human life does not redeem cosmic violence. It does not justify the death of stars. It does not turn indifferent laws into benevolent ones. But it does reveal something profound about what those laws permit. They permit, under narrow and temporary conditions, the rise of beings who can link blood to iron, bone to calcium, breath to oxygen, daylight to fusion, memory to metabolism, and the night sky to a history older than the earth. The chain does not become less real because we are the ones noticing it. It becomes more visible, and visibility changes the body again. A human body is not just an arrangement of stellar material. It is an arrangement of stellar material capable of building models of its own past. That may be the most unsettling turn yet, because it means the universe has produced at least one kind of thing that can be made by a process and then partially understand the process that made it, imperfectly, slowly, with many errors and revisions. Yes, but genuinely. The calcium in a skull can house a brain that learns where calcium comes from. The iron in blood helps oxygenate tissue that can infer why iron exists at all. Ancient nuclear history becomes available to a present mind through physics, chemistry, mathematics, and instruments built by hands made of the same old inventory. Dead stars leave behind matter. Matter, given the right interval, can leave behind understanding. There is no guarantee that this happens often in the cosmos. It may be common, it may be staggeringly rare. As of now, honesty requires restraint. We do not know how much life exists elsewhere, much less how much conscious, technological life. Exoplanet surveys have shown that planets are common. Many stars host them. Some worlds lie in temperature regimes where liquid water could in principle persist. Organic molecules are widespread. None of that yet resolves the harder question of how often chemistry crosses into life, how often life reaches complexity, how often intelligence becomes reflective enough to ask cosmological questions. The unknown remains real, but uncertainty does not weaken the immediate point. Whatever the cosmic frequency of consciousness, here it is, here, in this local system, ancient stellar matter has taken the form of beings who can stand under a delayed sky and understand that its light is old, that their bodies are inherited, that their star is temporary, and that the age of stars itself is a phase. That recognition does not lift us out of the chain. It deepens our place within it. And place is the right word now, because the final movements of this descent cannot be satisfied with abstract truth alone. The meaning of the story, if we are allowed that word in a disciplined sense, depends on how it returns to lived reality, not to vague cosmic belonging, but to the stark fact that each human life is a very brief episode inside a much longer material continuity. The body borrows old atoms, keeps them organized for a while, then returns them. Consciousness appears, learns a few things, loves a few things, fears a few things, and closes. The universe does not stop. The matter moves on. You do not own your materials. You host them briefly? That is not meant as consolation. It is meant as clarification. The self feels solid because it is close, but, materially, it is a temporary custody arrangement performed by metabolism. Your body exchanges atoms with the world constantly. The air, the water, the food, the minerals in blood and bone, all of it circulates. The continuity you experience as you is not the permanence of substance. It is the persistence of pattern for a while. The same is true, at larger scales, of stars and worlds. Pattern, held against dissolution, pattern, then release. And once that becomes visible, only one final return remains. The sky at the beginning looked calm, decorative, almost kind. Now it should look different, not less beautiful, more truthful. Those lights are the record of temporary structures burning through their fuel, holding collapse off, dispersing matter, enriching galaxies, making worlds possible, and, here, once at least, helping create beings who can understand that they are brief arrangements of violent ancestry. The stars are not your metaphor. They are your condition. And conditions are never neutral. That is what the sky finally teaches if you refuse to stop at admiration. A condition is not a backdrop. It is not passive scenery. It is the set of hidden permissions without which nothing else can happen. We spend much of life noticing events, and almost none of it noticing the conditions that make events possible. We notice the storm, not the atmosphere, the wound, not the body's prior stability, the extinction, not the climate window that had existed before it closed. In the same way, we notice stars as objects. We rarely notice them as enabling constraints, the long, controlled release of energy, without which planets freeze into irrelevance or burn into sterility. So, when we say the stars are our condition, we mean something more exact than ancestry. An ancestor belongs to the past. A condition belongs to the present and shapes the future. The dead stars gave us materials. The living star gives us a livable interval. Remove either one, and the story changes beyond recognition. Remove the older generations of stellar death, and Earth never acquires the chemistry required for rock, ocean basins, metal-rich geology, carbon-bearing complexity. Remove the long steadiness of the sun, and even with the right atoms in hand, life loses the stable gradient it needs to unfold. We depend, at once, on stellar history and stellar restraint. The doubleness matters because it prevents a common mistake. The phrase made of dead stars can lure the mind toward the past only, as though everything essential happened before we arrived. But that is not true. The past supplied the inventory. The present supplies the flow. Your body is assembled from inherited matter, yes, but it remains alive only because energy continues to move through this planet from an ongoing stellar source. The blood in a body and the weather above it belong to the same long arrangement. You do not just descend from stellar events, you live inside one. That makes sunlight harder to trivialize. A beam crossing a window looks harmless enough, soft, domestic, something you notice only when it lands on dust or skin. But sunlight is the present face of a much older transaction. In the sun's core, hydrogen nuclei continue to fuse under pressures no human body could survive for an instant. Energy begins there, buried in conditions so extreme that classical intuition is not enough to describe them. It diffuses outward over immense timescales, escapes the photosphere, crosses space, strikes Earth, warms atmosphere and ocean, drives convection, weather, circulation, evaporation, photosynthesis. Plants translate part of that flow into chemical form. Food webs inherit it, brains spend it, civilizations accumulate it, directly or indirectly, in crops, forests, fossil carbon, electricity. Sunlight on a table is not a mood. It is the visible edge of an astrophysical budget. That sentence is useful because it strips away the lazy separation between cosmic scale and ordinary life. The sun does not become important only when we discuss astronomy. It remains present in every metabolic act on Earth that depends on stored or current energy, which is to say almost all of them. In one sense, the difference between a star and a meal is absurdly large. In another, the meal is just one more local transformation of a flow that began in stellar fusion. The same is true of forests, winds, river systems, agriculture, oxygen abundance, climate patterns, and every biological rhythm tied, however indirectly, to the persistence of solar input. Life is local. Its allowance is not. That is why the sun occupies such a strange place in the human imagination. It is both overwhelming and easy to ignore. It is too large to grasp emotionally and too regular to feel dramatic. A supernova can seize attention because it is spectacular. The sun's greater achievement is monotony. Day after day, year after year, epoch after epoch. It continues to do the one thing Earth cannot replace. That repetition becomes invisible to us precisely because it is reliable. Catastrophe announces itself. Maintenance does not. But maintenance is where reality hides much of its force. A civilization learns this eventually, not through rhetoric, but through failure. Bridges do not collapse because gravity suddenly becomes stronger. They collapse when maintenance loses the argument. Bodies do not age because life is not real. They age because repair has limits. Ecosystems do not vanish because existence is fragile in the abstract. They vanish when the conditions sustaining them are degraded faster than adaptation can compensate. In every domain, continuity is achieved, if at all. Through ongoing work against disorder, the sun's life is not calm in the sense of passivity. It is calm in the sense of successful continuation. So is a forest. So is a biosphere. So, for a while, is a body. Again, the pattern repeats. Stars hold collapse off. Planets hold climate inside workable bounds. Organisms hold death off cell by cell. Minds hold coherence off moment by moment. None of these arrangements are permanent. None of them are guaranteed. But while they last, they create local worlds in which meaning, memory, and complexity can accumulate. The universe is not built from static things. It is built from temporarily sustained processes. And once you see that clearly, the old opposition between the personal and the cosmic weakens almost to the point of uselessness. Your life feels intimate because it is narrow in scale and close in sensation. Stellar history feels remote because it is vast and inaccessible to the senses. Yet both are episodes inside the same thermodynamic and material story. One is not symbolic of the other. One is continuous with the other. The body does not merely resemble the star in some poetic way. It inherits the star's materials, depends on stellar energy, and repeats, in miniature and by different mechanism, the broader truth that structure survives only by continuous expenditure. To live is to spend a local order. That line could sound bleak if read lazily. It is not bleak. It is exact. A living thing is not a static possession of form. It is an active maintenance of form through exchange. You breathe, you eat, you excrete, you regulate temperature, you repair tissue, you preserve ion gradients across membranes. You sustain the conditions under which thought can continue for another minute, another hour, another year. Stop the exchange, and the pattern begins to loosen. Not all at once, not theatrically, but lawfully. The body gives its borrowed structure back. This is not separate from the stellar story. It is one of its consequences becoming intimate. Because what stellar history gave the universe was not merely heavier elements, it gave it the possibility of local intricacy. Rocky planets, layered chemistries, atmospheres, oceans, mineral surfaces, repeating cycles, long-lived stars capable of underwriting them. The point of tracing our material ancestry to dead stars is not to flatter ourselves with cosmic romance. It is to understand that the ordinary world is already saturated with ancient violence that has been patiently reorganized into habitability. What looks calm now is often old catastrophe rendered usable by time. That should alter the meaning of ordinary objects. A stone is not just a stone. It is a planetary product impossible without stellar enrichment. A breath is not just a breath. It is local physiology using an element with a stellar prehistory. A cup of water warmed by afternoon sunlight is not just comfort. It is planetary chemistry held inside a thermal regime maintained by a star. A child growing, a tree ring thickening, a civilization harvesting grain, all are local signs that a particular arrangement of stellar inheritance and stellar steadiness is still holding. For now. That phrase returns because it has been present from the beginning, hidden under every beauty in the script. The star shines for now, the planet remains habitable for now, the biosphere persists for now, the body thinks for now, the age of stars itself lasts for now. This is not pessimism, it is the truth that gives contour to everything else. If conditions were permanent, they would vanish into background forever. We would never feel their cost. We would never understand their rarity. Finitude is what allows reality to become visible. So the question is no longer merely where your atoms came from. It is what kind of universe allows those atoms to become, briefly, someone. Not permanently, not safely, not by right, briefly, under conditions that had to be built by earlier deaths, sustained by present radiance, and protected within a narrow planetary corridor long enough for biology to become history and history to become self-awareness. A human life is not the point of the cosmos, but it is one of the rare places where the cosmos becomes legible to itself through lawful matter. And lawful matter does not remain arranged forever. That is the pressure gathering under the final movement now, because once you understand that the stars are your condition, not your metaphor, another realization follows almost unavoidably. Conditions can end, not dramatically in every case, not all at once, sometimes by exhaustion, sometimes by drift, sometimes by a threshold crossed too slowly to notice in a single lifetime. The sun will not always remain a stable sponsor of Earth's biosphere. The planet will not always remain temperate. The stellar age will not always remain rich with furnaces. Every enabling background eventually reveals itself as temporary. Which means the deepest fact hidden inside the phrase "you are made of dead stars" is not only ancestry, it is custody. You inherited matter, you inherited a habitable interval, you inherited light still arriving from a universe not yet dark. None of it belongs to you in the durable sense. It passes through. The atoms pass through. The energy passes through. The climate window passes through. Even the age of burning things passes through. And in that passage and for a while, matter feels, remembers, desires, fears, and asks what it is. The next step is to face that temporary custody without softening it into comfort. Because comfort is too easy a reward for a truth like this. If the script ended in comfort, it would betray the very structure it spent so long revealing. The universe did not become more intelligible by becoming gentler. It became more intelligible by forcing us to surrender one reassuring illusion after another. The sky is not immediate. Stars are not fires. Stability is not peace. The matter in your body is not local in origin. The age of stars is not permanent. Consciousness is not outside matter. At every stage, the deeper account has been less psychologically flattering than the first one, and yet more beautiful. Not because beauty cancels severity, but because severity was part of the beauty all along. We only misread it when we insisted that what is beautiful must also be soft, consoling, or made for us. The science never said that. The science said something stranger. It said that under indifferent laws, immense pressure, repeated catastrophe, and temporary balances, the universe can produce structure fine enough for oceans, metabolism, memory, grief, music, and thought, not forever, not everywhere, but here, for a while. That for a while is doing almost all the real work now. A human life is not just short compared with geological or cosmic time. It is short even compared with the planetary and biological systems that made it possible. Your body exists for an interval inside Earth's longer interval, which exists inside the sun's longer interval, which exists inside the stellar age of the universe, which exists inside a larger cosmological history that will continue without concern for the temporary arrangements it once allowed. At every scale, the same pattern returns, a narrower form nested inside a broader one, each borrowing stability from conditions it cannot fully control. This is not a hierarchy of meaning. It is a hierarchy of dependency. You depend on your organs depend on cells depend on molecular gradients, molecules depend on chemistry depends on elements. Those elements depend on astrophysical histories. Earth depends on the sun depends on fuel. It is spending. The stellar era depends on matter still being available in forms that can gather, ignite, and burn. None of these levels is optional to the one above it. None of them is permanently secured. A human life, then, is not a self-standing event. It is a temporary coherence suspended inside a stack of larger temporary coherences. The self feels central only because it is local. Juan de Dolores, Imbumwaville. This should not be heard as humiliation. It is clarification. The human point of view naturally mistakes intimacy for primacy. What hurts me feels more real than what happens in a galaxy. What I can touch feels more certain than what a telescope infers. But material continuity refuses that hierarchy. The calcium in a bone does not become more fundamental because it is now part of a person. The iron in blood does not become metaphysically privileged because it carries oxygen for a conscious organism rather than sitting in a stellar core or a planetary mantle. What changes is not the dignity of the atom. It is the arrangement, the context, the temporary function. And function is always historical. A phosphorus atom helping transfer energy in a human cell is playing a role that would have been meaningless before life existed. The atom did not change its essential identity to gain that role. The universe changed around it. Environments accumulated, conditions narrowed, new structures became possible. The same is true of carbon in neural tissue, calcium in a femur, sodium in a firing neuron. Matter does not carry purpose inside itself, waiting to be unlocked. Purpose, if the word is allowed at all, emerges locally when lawful structures persist long enough to make use of what matter can do. That is why the body is both ordinary and almost impossible. Ordinary, because bodies are common here. They are built, broken, fed, injured, repaired, reproduced. Life on Earth has been doing versions of this for billions of years. Impossible, because once you trace the full chain of permission backward, it becomes clear how much had to hold at once for even one body to happen. Not just one star, but generations. Not just atoms, but the right distribution of atoms. Not just a planet, but a rocky planet with a long-lived star, liquid water, cycling chemistry, relative climatic continuity, and enough time for evolution to continue past the innumerable points at which it could have stalled, ended, or taken different routes. A body is easy to find once a biosphere exists. It is very hard to earn a biosphere. This difference between local familiarity and deep rarity may be one of the most important emotional corrections science can offer. We become numb to things that happen around us often, even when their preconditions are extraordinary. A tree outside the window does not feel cosmically loaded. A child learning to speak does not feel astrophysical. The warmth of a hand, the contraction of a heartbeat, the ordinary continuity of another day. None of it announces its dependency chain, but the chain remains. The local miracle, if that word can be disciplined enough to survive here, is not that these things violate physics. It is that physics ever allowed them. Allowed, then not guaranteed. That second clause matters because it prevents the whole story from dissolving into reverence. Whatever this universe permits, it also takes back, not vindictively, not symbolically, lawfully. Stars exhaust their useful fuel. Planets drift through changing conditions. Biospheres are interrupted. Species vanish. Individuals die. The conditions sustaining one level of order cease to be available, and the pattern loosens. The materials remain. The arrangement does not. The body returns its atoms. The atmosphere reuses them. Rock reclaims some. Water reclaims others. Biology borrows again. Matter moves on with no obligation to preserve the name by which one arrangement once knew itself. You do not keep your form. You keep it for a while. And because the self experiences itself from the inside, that fact can sound cruel, but cruelty implies intention. Physics is not cruel. It is simply not organized around the emotional needs of temporary patterns. The same truth that removes consolation also makes the whole story more honest. You are not a permanent owner of old atoms. You are a brief custodian of them. The coherence you call a person is a high-order event in which inherited matter is held in a specific pattern long enough to love, to fear, to remember, to build, to grieve, to ask questions. Then the pattern yields. The matter does not mourn the transition. The pattern would, if it could continue. But continuation was never part of the contract. And this is exactly why the stars matter so much to the final meaning of the story. Because stellar life established the template before life on Earth ever existed. A star persists by spending itself. It shines by consuming the conditions that allow it to shine. That is not identical to life, but it rhymes with life more than the old passive image of stardust ever could. Bodies also live by expenditure. They maintain their order through constant throughput. They survive by processing gradients, fuel, air, water, information, repair. The difference is one of mechanism and scale, not of underlying grammar. Stars spend their fuel to remain stars. Organisms spend their gradients to remain alive. Minds spend their activity to remain coherent. Everything luminous pays rent to time. That line may be the cleanest compression of the whole script so far. The star pays, the planet pays, the biosphere pays, the body pays, consciousness itself pays, burning through ordered states in order to maintain a world model for one more moment. There is no free stability anywhere in the story. Only balance is achieved by spending something that eventually runs thin. Once that is visible, the emotional residue begins to change shape. At the start, the sky offered one kind of feeling, distance mistaken for reassurance. Then came rupture, severity, consequence, inheritance. Now, the deepest feeling available is neither comfort nor despair. It is a clearer kind of awe, an awe with its sentimentality removed, not how lovely that we belong to the stars. More like, how astonishing that matter passing through so much violence, under so little promise, could ever hold itself together long enough to become this. This, a person standing under a night sky, warm breath and cold air, a pulse moving iron through blood, calcium holding the frame upright, sodium and potassium shaping neural excitability, oxygen entering, carbon dioxide leaving, photons from the sun stored in food, then spent in thought, old stellar material, temporarily organized into a witness capable of understanding, however incompletely, that the witnesses and the stars belong to the same unfolding order. That is a harder beauty than comfort can hold. And it prepares the final return, because now the opening image can be seen without innocence. The night sky is still beautiful, the stars are still distant, the darkness is still deep enough to make a human being feel small, but the meaning of that smallness has changed. You are not small because you are irrelevant to the universe. You are small because you are a brief local pattern inside processes vastly older and larger than yourself. Yet, that local pattern is made of their products, sustained by their energy, and capable of reading some of their history. Small, yes, but not detached. Temporary, yes, but not trivial. The final task is to hold all of that at once without retreating into slogan, comfort, or despair. Because once you understand what "made of dead stars" really says, the sentence stops being a decorative thought. It becomes a way of seeing everything you are. Everything you are, but also everything you are not. That distinction matters now, because the story can still be misunderstood in one last way. Once people hear that the body is made of ancient stellar matter, there is a temptation to dissolve the person entirely into cosmos, as if individuality were merely a sentimental illusion and only atoms were real. The opposite temptation is just as strong, to hear the cosmic ancestry, nod at it, and then retreat into the ordinary sense that a human life remains fundamentally separate from the rest of material history. Both reactions are too simple. One erases the pattern in favor of the materials, the other erases the materials in favor of the pattern. But reality keeps both. You are not only your atoms. If you were, then a corpse would be indistinguishable from a living body in every important sense. And it is not. Most of the matter remains for a while. The pattern does not. The continuity of metabolism, regulation, sensation, memory, response, anticipation, the organized instability that made a person possible, has failed. This is why a human life cannot be reduced to inventory alone. Carbon, oxygen, hydrogen, nitrogen, calcium, phosphorus, sulfur, sodium, potassium, iron. The list is real, but the list is not a mind. A periodic table is not a biography. Materials matter, but arrangement matters too. History matters too. Timing matters too. And yet you are not only your pattern either. Patterns do not float free of substance. Every memory requires a substrate. Every thought requires ions, membranes, neurotransmitters, proteins, oxygen, glucose, heat regulation, a living brain whose physical conditions remain inside narrow bounds. The self may experience itself as inward and coherent, but that coherence is inseparable from a material arrangement inherited from the older universe. If the atoms had not been forged, if the planet had not formed, if the sun had not remained stable, if biology had not crossed so many improbable thresholds, there would be no pattern here to defend metaphysically. A person is neither mere matter nor something exempt from matter. A person is matter under an extraordinarily specific organization, sustained for a while. That formulation is less flattering than most spiritual consolations and more dignifying than pure reductionism. Less flattering because it refuses to treat consciousness as a cosmic entitlement. More dignifying because it recognizes how astonishing the organization itself is, not miraculous in the sense of violating law. Miraculous, if the word is tolerated, in the sense that lawful processes under indifferent conditions ever produce something this intricate. A human being is not the point of the universe, but a human being is one of the most refined temporary arrangements we know the universe can make. That should sharpen the meaning of mortality rather than soften it, because death is not just the end of a life in the emotional sense. It is the failure of the specific pattern that kept ancient matter organized into a self. The atoms remain available. The history inside them remains. The stellar ancestry remains. What does not remain is the active coordination that made those atoms this person, here, now, with these memories, these fears, these loyalties, this voice. The cosmos does not lose matter when a person dies. It loses a pattern. And patterns are the rare thing. Hydrogen is abundant. Helium is abundant. Even stars, by the standards of one galaxy, are abundant. But a habitable planet is rarer than raw gas. Life is rarer than habitable chemistry. Complex life appears to be rarer still, at least so far as we can honestly confirm. Reflective consciousness, the kind that can reconstruct stellar nucleosynthesis, understand delayed starlight, and recognize itself as temporary custody of old matter, is rarer again. The farther you move from inventory toward organization, the narrower the corridor becomes. That corridor is where value enters. Not as some mysterious cosmic substance sprinkled onto consciousness, but as a consequence of rarity, contingency, and local complexity. A star can die and enrich a galaxy. A galaxy can produce more stars. Matter is not in short supply on cosmic scales, but a living mind is a much more delicate achievement. It depends on a stack of conditions so specific that once the pattern appears, it carries a different kind of weight, not because the universe announces it as sacred, because anything this contingent, this structured, this temporary, and this capable of experience acquires gravity from its very improbability. The body is common only from very close up. From farther back, it is an edge case of physics. This is one reason the phrase, "you are made of dead stars," should never end as a flattening gesture. It should not dissolve a human life into generic cosmic dust. Quite the opposite. It should reveal how much had to happen for old stellar matter to become someone rather than remain only something. The passage from something to someone is not magic, but neither is it trivial. It is one of the steepest climbs matter is known to make. And that climb does not erase the older history beneath it. It keeps it active. When you think, ancient elements participate. When you grieve, stellar products hold the body upright through the grief. When you speak, breath moves across tissues built from inherited chemistry. When you look at the night sky, matter forged in older stars is used to interpret the light of current ones. There is an elegance almost too severe to sound invented. The universe does not merely contain the record of stellar history. In at least one place, stellar history became capable of reading itself through living matter. That does not mean the reading is complete. It is partial, late, and perhaps temporary on civilizational timescales as well as individual ones. Knowledge can be lost, worlds can fail, biospheres can narrow, civilizations can collapse before understanding spreads or before it is preserved. Even now, much remains unresolved. We do not know how often life emerges elsewhere. We do not know how often intelligence survives long enough to build science. We do not know whether the cosmos is full of observers or whether consciousness is one of its rarest local accidents. We do not know the full long-term behavior of every physical process that will govern the far future. Honesty has to stay awake here. Ignorance is part of the architecture too. But uncertainty does not erase the achieved truth in front of us. Here, now, on this planet, in this era, matter forged in ancient astrophysical violence has become organisms capable of tracing their own ingredients back through dead stars, living stars, planetary history, and the finite speed of light. That is enough to transform the meaning of the ordinary without pretending we have solved the whole universe. And the ordinary is where the transformation has to land. Not in a slogan, not in a poster line, not in a sentimental cosmic creed, in the ordinary, in food, in weather, in breath, in the warmth of daylight on skin, in a hospital monitor registering electrical patterns in a body built from old atoms, in a child learning language with a brain sustained by oxygen carried on iron that once belonged to stellar history, in a hand touching stone, both hand and stone, impossible without the repeated enrichment of the universe by generations of stars. In the old human habit of looking up and asking what all of this is. The answer is not simple enough to console us, but it is clear enough to change us. The clear version says this: you are a temporary pattern made from ancient materials, sustained by current stellar flow, living during a finite era in cosmic history when such patterns are still possible. Your body is inherited, your energy budget is borrowed, your continuity is maintained, not given. Your awareness is local, fragile, and real, and the sky above you is not distant decoration. It is the larger process from which both your materials and your conditions emerged. That should alter the emotional register of being alive. Not toward despair. Despair is too self-regarding, and not toward comfort, because comfort would soften the truth back into something smaller than it is, toward a more exact form of seriousness, the kind that appears when you realize that your life is not cosmically central, yet is still one of the narrow intervals in which ancient matter has become capable of feeling, choosing, and understanding. Seriousness, because the interval is brief. Seriousness, because the pattern can fail. Seriousness, because inherited materials and borrowed light have, for a while, become a witness. That witness is you, not eternal, not exempt, not outside the chain. Inside it, briefly articulate within it. And once that is fully visible, the final return to the opening sky becomes almost unavoidable. At the beginning, the stars looked calm because distance edited out their violence. Now they should look calm in a different way. Not because they are harmless, but because their most radical truth no longer needs spectacle to be felt. A point of light can now carry compression, fusion, delay, collapse, enrichment, planetary possibility, and the long thermodynamic generosity by which Earth was allowed to remain biologically interesting for a while, the sky has not changed. Your reading of it has... It is no longer a ceiling of lights. It is a field of conditions, losses, and inheritances. And if that is true, then the last step is not to ask what the stars are. It is to ask what it means to be one of the temporary things their deaths made possible. It means you should stop imagining your existence as self-originating. Not because individuality is unreal, but because independence is. A human life feels self-contained from the inside. That is one of consciousness's most convincing illusions. The body seems to begin at the skin. Thought seems to begin in the mind. The day seems to begin with waking, but none of those boundaries are true in the deeper material sense. The skin is porous. The body is exchange. Thought depends on air, water, minerals, heat, food, history, language, ecological stability, and a star still willing to hold its own collapse off for another morning. Even the cells in your body are temporary participants in larger flows. You are not a sealed event. You are an interruption in circulation. That should not make you feel unreal. It should make reality harder to misread. Because one of the great seductions of ordinary life is the feeling that the world is made of finished things. A person, a tree, a stone, a star. As though each object arrives complete, self-sufficient, and separate from the long processes that keep producing and dissolving such forms. Science keeps undoing that convenience. The tree has captured light and atmospheric chemistry, held briefly in cellulose and water. The stone is planetary cooling, mineral sorting, pressure history. The star is gravitational concentration held open by fusion. The person is inherited matter, ecological throughput, neural activity, memory, and time. None of these are finished things. They are temporary achievements. You are one of them. That may sound like diminishment until the full scale of the alternative is faced. The alternative is not that you are secretly permanent, or exempt, or metaphysically detached from the rest of nature. The alternative is illusion. And illusion is always cheaper than truth. It makes the self feel larger while making reality smaller. It gives easy emotional rewards by hiding dependency, contingency, and cost. But once the chain is visible, dead stars, enriched clouds, forming worlds, a stable sun, a working biosphere, a metabolism that keeps local order alive, the cheaper story becomes difficult to tolerate. You cannot honestly call yourself self-made after this. Not when your bones depend on calcium older than Earth. Not when your blood depends on iron whose existence required astrophysical thresholds no body could survive. Not when every calm afternoon depends on a star managing its internal crisis successfully enough to keep Earth inside a workable energy regime. Not when the air in your lungs depends on biological and planetary history, layered atop elemental histories that began in stellar interiors. Not when the very possibility of consciousness depends on the narrow continuity of a living brain built from ancient inventory and fed by present flows. Selfhood is real. Self-sufficiency is the fiction, and once that fiction falls away, another one weakens with it. The idea that meaning must come from permanence to matter. Human beings often smuggle this assumption into their deepest fears without noticing. If something ends, it must have been less real. If a pattern is temporary, it must be insignificant. If a life is brief against cosmic time, it must be negligible. But the universe keeps presenting the opposite pattern. Stars matter because they are temporary. Habitable worlds matter because their conditions are contingent. Biospheres matter because they can fail. Minds matter because they are rare forms of order maintained only for a while. Permanence is not what gives a thing weight. Vulnerability does. A diamond is not precious because carbon is rare. Carbon is common. Diamond is precious because of arrangement. A melody is not meaningful because sound itself is hard to produce. Sound is easy. The melody matters because of order and time. A human life is not weighty because atoms are scarce. Atoms are everywhere. It is weighty because the arrangement is difficult, contingent, and perishable. The same is true, in another register, of stars. Hydrogen is common. A star is a particular, temporary way of forcing that common substance into a prolonged act of consequence. That parallel should land now with more force than it would have earlier. A star spends itself to remain a star. A body spends itself to remain alive. A mind spends ordered activity to remain coherent. None of these patterns are permanent possessions. All are maintained states. All require throughput. All eventually fail. The grammar has been the same from the beginning. What changes is the mechanism, the scale, and the intimacy with which we experience the failure. We watch stars die from far away, late, through delayed light and theoretical reconstruction. We experience bodily fragility from inside, in pain, fear, aging, and grief. The emotional texture differs. The structural truth does not. Everything organized pays a price for staying organized. That is not a tragic exception in the universe. It is the rule. And now the phrase made of dead stars should have become almost too narrow to carry the full truth by itself. Yes, dead stars supplied much of the material. Yes, their deaths enriched the galaxy. Yes, your body contains their chemical descendants. But the deeper point is no longer just origin. It is participation in a larger pattern of temporary order emerging under severe conditions. You are not merely made from stellar history. You are one more local continuation of its logic, matter organized for a while by the lawful expenditure of energy. That is why the body is not just ancestry. It is inheritance in active use. Your skeleton is not a memorial to calcium's origin. It is calcium now serving structure. Your blood is not a museum of iron's astrophysical biography. It is iron now serving transport. Your neurons are not abstract symbols of elemental continuity. They are present-tense machinery, using sodium, potassium, oxygen, glucose, and phosphorus in real time to preserve a world model for another instant. The past is not dead in you in any sentimental way. It is operational. Ancient matter is busy again. That is one of the hardest and most beautiful things the story reveals. The universe is not divided cleanly into dead events behind us and living events here in front of us. The so-called dead stars are still active in consequence. Their products are underfoot, in the mantle of the earth, in mountain ranges, in ocean salts, in plant tissue, in animal metabolism, in the chemistry of every living cell, in every brain that can recognize the sky as something deeper than scenery. Death in the stellar sense did not remove them from the story. It changed their role. And changing roles is perhaps the closest thing the cosmos has to continuity. A star becomes a remnant. A remnant enriches a cloud becomes a system produces a world hosts chemistry hosts life produces consciousness names the stars and slowly discovers that the names were late. Nothing remains the same thing, yet nothing falls outside the chain. Even endings are usually transitions into altered participation, not survival of the self in any simple sense. Survival of consequence. That phrase matters because it keeps the script honest. Science does not offer immortality to the person. It does offer continuity of material and causal consequence. The self does not persist as a stable owner of atoms. The atoms persist through other forms. The pattern does not remain intact forever. Some consequences of the pattern do. Knowledge, care, damage, memory in others, institutions, tools, genetic inheritance, ecological alteration, cultural traces, in the cosmic frame, even those are brief, but brevity does not erase them. It places them where all meaningful structures have always lived, inside time, under cost, without guarantee. You were never promised more than an interval. The stars were not either. That is why it would be wrong to end this story in despair. Despair secretly expects reality to have owed us something steadier. It treats finitude as betrayal, but nothing in the architecture ever suggested permanent custody. Stars borrow their luminous interval from fuel. Planets borrow their habitable interval from balance. Bodies borrow their living interval from metabolism and circumstance. Civilizations borrow their stable interval from ecological and social conditions they can lose. The pattern is universal enough that outrage at impermanence begins to look less like wisdom and more like refusal. Yet resignation would be wrong too, because resignation flattens the interval, treating the temporary as already empty. And temporary things are not empty. They are the only things the universe has ever made that can hold complexity in a form we can witness. Every song, every forest, every pulse, every idea, every dawn, every scientific inference about dead stars and delayed light has existed as a temporary arrangement. The fact that it passes does not hollow it out. It is the reason its structure is worth noticing at all. A star shines, a body lives, a mind understands. None of these verbs are permanent. All of them are real. So, what does it mean to be one of the temporary things stellar deaths made possible? It means you are not standing beneath the universe as an outsider trying to interpret it. You are one of its late internal events, a local organization of ancient matter, sustained by present energy, capable of tracing some of the conditions that made it possible. Your life is not separate from cosmic history. It is one of the moments in which cosmic history becomes intimate enough to feel from the inside. Not forever, not on all worlds, not even here for very long, but here and now. That is enough to alter the meaning of the sky completely. Because now, when you look up, you should not see comfort in the old sense, not decorative distance, not harmless lights. You should see a field of temporary furnaces, some already gone in their current form, some still holding collapse off, all participating in the long conversion of simplicity into structure and structure into further possibility. You should see the source of many of your materials, the condition of your present world, and the larger era whose borrowed brightness you are still lucky enough to inhabit. The sky was never just above you. It was always inside the story of what you are. And now the sentence can finally be said without lying. You are made of dead stars. Not in the soft way the phrase is usually offered, not as a decorative consolation, not as a cosmic greeting card, but in the harder, cleaner sense that the words can bear after everything else has been stripped away. The heavier elements in your body exist because earlier stars lived under pressure, changed their interiors, reached their limits, and in many cases died in ways violent enough to return enriched matter to the galaxy. The world beneath your feet exists because that matter later gathered again. The air, the stone, the sea, the iron in blood, the calcium in bone, the phosphorus in cells, the oxygen moving through your lungs, all of it belongs to a history that began long before Earth and was never remotely obligated to produce anything like you. And yet here you are. That is not a sentimental line. It is the starkest fact in the story. Here you are, ancient matter, locally organized, inherited chemistry, temporarily animated, old stellar consequence held, for a while, inside a body capable of asking what its materials once were. The chain is long, the interval is brief, both are true at once. The body does not become less remarkable because its materials are old. It becomes more remarkable because old materials are all the universe ever had to work with. And somehow, under laws that make no emotional concessions, those materials became this: a face, a voice, a memory, a fear of loss, a hand warmed by sunlight, a mind capable of standing under the night and feeling the pressure of what it now knows. The pressure is important, because the truth should press on you a little. It should make the ordinary world feel denser than it did before. Not mystical, denser, more causally loaded. A glass of water is no longer just a local object. It belongs to planetary chemistry on a world made from enriched matter. A breath is no longer just a private reflex. It is oxygen with a stellar prehistory moving through biological systems under the allowance of a star still burning. Bone is no longer only anatomy. It is mineral structure built from elements the early universe could not make for you. Blood is no longer only warmth. It is transport performed by iron that once marked the fatal limit inside massive stars. Even daylight should feel altered now. Less innocent, more exact. Not just brightness, but the present face of an ongoing stellar expenditure without which your world would lose its coherence. The ordinary was never ordinary. It was inherited complexity rendered familiar by repetition. That may be the final illusion the script had to dismantle. Not only the illusion that the stars are calm, Not only the illusion that stardust is gentle, but the illusion that familiarity tells the truth about significance. Most of what matters most becomes background if it persists long enough. The sun rose yesterday, so its rising feels trivial. You have bones, so they feel unremarkable. You breathe constantly, so oxygen disappears into utility. The sky appears every night, so distance edits out violence and delay. Familiarity shrinks the visible weight of things. Science, at its best, reverses that shrinkage. It returns weight to what repetition has made invisible. And what it returns here is immense. It returns the knowledge that the sky above you is not a ceiling of ornaments, but a field of processes, some ongoing, some already ended, all part of the long thermodynamic work by which the universe turns simple matter into richer arrangements and then gives those arrangements back. It returns the knowledge that your body is not local in origin, even though it is painfully local in feeling. It returns the knowledge that consciousness is not outside matter, but one of matter's rarest temporary behaviors. It returns the knowledge that the age in which stars still shine in abundance is not permanent, and that you happen to exist while the furnaces are still on. That timing should matter. Not because it makes us chosen, it does not. Not because it makes us central, it does not. But because it makes us situated. We are late enough to inherit dead stars, early enough to inherit living ones, late enough for chemistry to have become richly complicated, early enough that complexity is still energetically affordable on worlds like ours, late enough that ancient light reaches instruments and minds capable of reading it, early enough that those minds still stand in a luminous universe instead of a colder one. We are not the climax of the story. We are one of its brief readable intervals. A readable interval made of unreadably old matter. There is something severe in that combination, and something deeply human. We have always wanted to know where we came from, but we often wanted the answer to arrive in a form that would protect us from scale, from contingency, from the indifference of physics. This answer does not protect us. It does something better. It places us accurately. It says, you are not outside the universe, not dropped into it, not merely observing it from some safe conceptual ledge. You are one of the things it has done, one of the temporary forms into which it has arranged old matter under local conditions, one of the places where ancient stellar inheritance became metabolically alive and, for a moment, articulate. That articulation does not last. This is the part no honest ending should try to blur. The body will not keep its current pattern forever. The sun will not keep underwriting Earth forever. The stellar era will not keep filling the dark forever. The continuity you experience as self. The climatic continuity a biosphere experiences as habitability. The luminosity a star experiences as successful resistance to collapse. None of it is indefinite. Every balance in the story is conditional. Every permission expires. The same laws that made structure possible ensure that structure must be maintained at cost, and therefore cannot be owned permanently. But expiration is not the opposite of meaning. It is the condition under which meaning can appear at all. A note matters because it is played and passes. A season matters because it turns. A life matters because it is not indefinitely repeatable in its exact pattern. A star matters because it spends itself into consequence. If permanence were the measure of value, the universe would be almost empty of value. Everything we have learned says otherwise. Value enters where organization is difficult, where continuity is conditional, where the interval is brief enough to be vulnerable and structured enough to feel. The stars do not become less magnificent because they die. They become legible through what their deaths allow. A human life does not become less real because it is temporary. It becomes one of the rare forms in which inherited matter can feel the cost of temporariness from the inside. That is what you are. Not a symbol, not an exception, not a cosmic accident in the dismissive sense, nor a cosmic destiny in the flattering one. Something more exact than either. A temporary organization of ancient matter, under present stellar light, during a finite era in cosmic history when such organizations are still possible. Your bones remember dead stars without knowing it. Your blood remembers them functionally. Your breath depends on them indirectly. Your brain. if it is fortunate enough to encounter the chain clearly, can remember them consciously. Matter that once had no voice now borrows one through you. And through that borrowed voice, the night sky becomes impossible to see the old way. Look up now, and the lights are still beautiful. They have lost none of their beauty, but the beauty is no longer passive. It is charged with pressure, delay, expenditure, inheritance, and loss. Some of those stars are younger than the Earth. Some are older. Some are living slowly. Some are spending themselves extravagantly. Some may no longer even exist in the form you see, their light still crossing the dark long after their interiors have changed or collapsed. Each point of light is a report from a process. Each report arrives late. Each late arrival participates in the conditions from which worlds and bodies and minds emerged. The sky is not serene because it is safe. It is serene because the violence has been translated by distance into silence. The silence was never innocence. It was only scale. And beneath that scaled silence, the final truth remains. You are not beneath the stars in the simple way you once imagined. You are not separate from them. You are not merely admiring them from afar. You are one of the temporary things their existence and their endings made possible. A brief local pattern of old elements, a small coherence inside larger coherences, a witness formed from inheritance, speaking under borrowed light while the age of burning things still lasts. One day the stars will thin. One day even the patient ones will go dark. One day the universe will be less generous with light than it is tonight. But this is not that night. Tonight, the sky is still full of ancient furnaces. Tonight, their old dead have become rock, ocean, air, blood, bone, and thought. Tonight, matter that passed through collapse and fire has gathered itself into someone who can stand in the dark, look back at its own beginnings, and understand, however briefly, however incompletely, that the calm above was never calm at all. It was the long afterglow of everything that had to die for you to be here.